Okay. Good morning, Prof. Rosita.
Good morning, everyone.
Now we are in time. Sorry for this morning.
It's okay.
All right, then. Shall we begin now?
Yeah. So, do you want to say something, or I can start immediately?
At least I will say Assalam.
Yeah. Okay.
Yeah.
Yes. Yes.
Assalamualaikum warahmatullahi wabarakatuh. Dear students, dear participants, dear colleagues. As we acknowledge, we will start another lecture from Prof. Rosita for today. And we are talking about the fourth technology revolution. It must be very interesting. So let's hear what this knowledge about. So good luck, and shall we start with Bismillahirrahmanirrahim. Okay, time is yours, Prof. Rosita.
Thank you, Bu Un. Okay, I try to share my slide. Can you see this one? Oops.
Yeah.
Okay, is it?
Sorry, Prof. Rosita, just before you start, I forgot to say that, we will have class until about noon, 12 o'clock. So in the middle, we can have a rest for question and answer for the first one at around 10.
Okay.
Do you mind?
Yeah. Okay, it's okay for me.
All right, then. So you will have half way, and then we have a short of question and answer, and then you can start again, and then we will finish around 12 o'clock. Thank you, Prof. Rosita.
Okay, thank you, Bu Umi. Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning to all students, and maybe if there is lecturer here, I hope everyone is doing well and still in high spirit to gain new knowledge, hopefully. Our topic this morning is on the application of fourth industrial revolution technologies to marine aquaculture and for future food. Yeah, it is a very relevant topic, I think, for our current situation, whereby, IR 4.0 is, taking place like several years ago, and we are trying to adapt ourselves to make use of these technologies to remain productive, to remain sustainable in whatever we are doing. So if you have question, just write, or you can stop me, you can raise your hand, but normally I can, when I'm sharing my slide, I cannot see the question in the chat box or someone raising hand. I cannot see that. So you can ask the moderator if you have question during my lecture, but I will try to answer your question after the session. Okay?
Yes, Prof.
Okay. What is IR 4.0? I means industrial, R is revolution. So industry 4.0. We heard about this like few years ago. So if you see this diagram, we started with so-called industry 1.0, whereby we are only depending on the mechanization, only steam power, weaving loom at that time. And then industry 2.0, we are moving a bit more advanced, like, we are starting to have our mass production, assembly line, and then we have starting to utilize electrical energy, and then after that industrial 3.0, whereby we already have our automation technology. Computers and electronics were started at this era. And now we are in this industry 4.0, whereby cyber physical system, Internet of Things, IoT, and networks are utilized widely. Okay, let's see. Hang on, yeah. I just want to show you so that you have a better idea on what is IR 4.0.
If you wear glasses or contacts, you must see this. An award-winning doctor reveals an astonishing, natural way to reclaim the 20/20 vision you.
The fourth industrial revolution has begun, and you have the chance to be part of it. This isn't going to be like before. It's not about the steam that powered our factories in the first revolution, or the mass production model that dominated the second, or even the emergence of computer-driven systems from the third revolution that we're living in today. Industry 4.0 is about connectivity. It's an opportunity to radically change the way industry responds to the needs of society. As previous industrial revolutions were led by innovations in manufacturing processes and systems, the advancement of Industry 4.0 will be driven by a smart, interconnected, pervasive environment. The opportunities for disruption are huge, and those left behind will feel it acutely. There is still space for leaders of this new revolution to emerge, but the race has already started. Understanding what current leaders are doing will help you join them. KPMG formally examined what those trailblazers were doing in their factories and their offices, and it revealed some thought-provoking findings. Our research highlighted a number of areas that current Industry 4.0 leaders are focusing on. Leaders are planning ahead with clear strategic vision, driven by performance and tying investment to proven opportunities for growth, progress, and innovation. They are focused on discovering how smart products and processes can be developed. Integration is key. The major players are moving away from isolated silo-driven development, which limits scope and value of new projects. Instead, they are moving towards large-scale and proactive integration across their enterprise and among their customers, supply base, and products. To ensure they are aware of every possible opportunity Industry 4.0 technology has to offer. Perhaps most importantly, they are not afraid to think big and act bold. This means nurturing innovation, developing disruptive thought processes aimed at devastating the status quo, and looking for opportunity in every element of their value chain, from which products are designed and how they are produced, to who they are sold to and how they are purchased. Your organization may be radically different in the future, with a range of products, services, and processes you can't currently predict. Do you want to join the leaders of Industry 4.0? Can you afford not to? Then our advice is, plan ahead. Fight radical change with integrated radical action. And embrace the fact that it's time for manufacturers to step up and start making smart, bold moves. If you don't, you could be left behind. You have this chance. Let us help you take it.
Okay, I think you get some rough idea about what is IR 4.0. Basically, this is just a video to give you some basic idea. What is it all about? You know, IR about 4.0 normally.
Ya, Kak, tak transfer ya, wes. Ayo ya, aku udah.
heavily on interconnectivity, automation, machine learning, and also real-time data. Basically, IR 4.0 started like in 2011, but maybe in our country it's slightly later, yeah, slightly later than 2011. Okay, how do we relate with our industry, aquaculture industry? Let's have a look at the status of our industry. Fish demand is projected to increase in the range of about 112 to 114 million tons by 2030, which is about 9 years from now. So it requires additional like 30 to 32 million tons of fish. So this is a great challenge that requires a real transformation, meaning how do we achieve this 30 million tons in 9 years? If we were to stick to the old technology. So that is the thing that as aquaculture people, we need to think on how are we going to continue feeding the people with our fish. So there must be new perspective. We can't depend on the capture fisheries. If you see landing from capture fisheries are unlikely to increase due to depletion of wild stock, impairment of ocean ecosystem. You know, I have touched about a little bit about ocean acidification, rise in temperature, you know, the global warming phenomenon. So very, very unlikely that our fish catch from the wild will be in increasing trend in the next few years. So instead, at the moment, it is on the static production when it comes to fish landings from the wild. So aquaculture is the only alternative, the only hope that we have for our future. So that is why we need to think of a new approach, of a new technology to increase our supply of fish from aquaculture. So aquaculture production should increase to ensure adequate supply. So how? Okay, IR 4.0 and our aquaculture industry. IR 4.0 offers a range of technologies and some can be adapted for aquaculture system. Yeah, it is appropriate to apply the term aquaculture 4.0 to aquatic farming driven by these disruptive technologies. All IR 4.0, a wide range of technology that can be also used in aquaculture industry. Some interesting work has appeared in this area, and we will have several examples later on. When the sustainability is taking a center stage in food production, remember about United Nations SDGs. Tomorrow I will touch on this specifically. Yeah. So it is necessary to generate a strategic framework comprising the purpose or goals and drivers aligned with the United Nations Sustainable Development Goals to resonate with the global narrative. Okay, when we said technology, we are talking about different types of technology. Yeah, we will see what are the different technology that we related to IR 4.0. Okay, certain new terms such as precision aquaculture, smart aquaculture, or smart farming, digital farming are associated with technology intensification in aquaculture. If you search journal articles or even books, there are now several publication, review paper or original research already published in this focus, yeah, the smart farming, the precision aquaculture. Precision agriculture is also another branch of smart agriculture, and then of course the digital farming. These terms are often used interchangeably, but there are subtle differences. Precision aquaculture refers to the use of digital techniques in monitoring and optimization of the culture system. This implies regulating the supply of inputs in amounts exactly needed to prevent waste, reduce costs, and minimize environmental impacts. I've visited a mango farm somewhere in, I don't remember where I visited the place, maybe Thailand. There are growing mangoes using this smart farming concept, whereby the plant, the mango plant, the mango seedling were equipped with what do you call a fertilizer tube, which is controlled by a digital technology, whereby this particular plant will receive the exact amount needed. The same concept with fish nutrition requirement that we discussed. Yeah, we don't want to give more or less than what it needs, because if you give more, it will be a waste or increased cost, or if you provide less, it will maybe affect the growth of your fish. So the same concept applies here. Precision aquaculture means everything has to be precise. Ngam, very tepat, you know, the amount of the fertilizer. Same thing of aquaculture, the amount of feed, for example, amount of oxygen in water. So this is the concept of precision aquaculture. Smart farming anticipates application of information and data technologies in effective ways for better results. Okay, continue with technology intensification. Digital aquaculture combines elements of precision aquaculture and smart aquaculture to advance the technology. So meaning we can use two different types or more technologies to form a smart farming system. The emergence of the Internet of Things, IoT, big data, I'm sure you heard about big data, artificial intelligence, 5G networks. We are now at our 5G, I think. We are still on our 5Gs. So when we said we are now at 4G, I'm using 4G, I think. But if it's 5G, imagine it will be more capacity, more speed, faster, no delays. If there is also very small delay, very short delay. So this is what the technology going to enter. Cloud computing and robot technologies make intelligent aquaculture possible. So a comprehensive review of the application of various technological tools, including sensors, robot, 3D prints. I will share you this interesting 3D printer, drones, artificial intelligence in aquaculture development has been published recently. So if you want to know more later, you can search, a review on this topic. Intelligent aquaculture involves the following aspect. First, collecting information through various temperature, for example, humidity sensors, carbon dioxide sensors, light sensors, DO, various other sensors for water qualities, and also the camera, digital image data acquisition equipment. And then transmitting this collected data to the control center through communication nodes. Yeah, this information may include growth, environmental parameters, operation, and then resource allocation. All this can be integrated with this technology. And then data processing, decision making performed in the cloud platform. Feedback of decision to each execution equipment and the intelligent and automatic carrying out of operation to realize sustainable, high efficiency, high quality ecology, health, and intelligence aquaculture. I'm sorry if some of the terms sounds new to you, but as we go to the next slide, I think it will become more familiar and familiar. Okay, let's have a look at what are the available technology that we can utilize in our aquaculture industry. The first one is sensor technology. This is a technology that uses sensor to acquire information by detecting the physical, either physical or chemical or biological property quantities and convert them into readable signal. So, and then if this is the thing that you want to measure, whatever like growth or water quality, amount of feed, sensor detect this quantifiable physical, chemical, biological, and then they can convert it into something that can be read, such as electric signal. This is the output that you will see later on. Okay, sorry, a lot of writings here. Sensor plays an essential role in the development of intelligent aquaculture and developing rapidly now. Breakthrough in core sensor technology, development of modern information technology, rapid development of cloud technology, big data platforms, the enhancement of application, the promotion, all mean that the application of sensor will be more extensive in breeding. We can apply it in breeding our fish, in grow out, and then aquatic product storage, transportation, processing, operation, and also maintenance. And at the same time, increasing demands on sensory technology are driving development of novel sensor with high accuracy, high performance, multifunction, low cost, miniaturization, networking capacity, and longer service life. So these are the qualities that the industry offering now. This has opened up prospect for the integration of sensor with the further development of new technologies in modern physics, such as nanotechnology using laser, infrared, ultrasound, microwave, optical fiber, strong magnet, radioactive isotope, and many more. Yeah. So other important trends in development of sensor include integrating the micrometer level, sensitive sensing element, signal detection, conversion processing unit, the CPU, central processing unit of the computer, and to develop multifunctional small portable sensor in a wide application range, yeah, high reliability and long service life again. And biosensing is also another future direction, yeah, using biology-based sensor. It is believed that with the development and application of new sensor in all aspects of intelligent aquaculture, field monitoring, remote debugging, remote fault diagnosis, remote data collection, and real-time operation can be realized through Internet of Things, IoT, enabling unmanned intelligent aquaculture production. So we don't need human anymore in the future, maybe. So let's have a look at another technology, what we call IoT, Internet of Things. IoT is a system of interrelated computing devices, mechanical and digital machines, objects, or even animals or people that provided with a unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. So this is how advanced technology can be. A thing here, the IoT, the T, a thing in the Internet of Things can be a person with a heart monitor implant, for example, a farm animal with a biochip transponder, or an automobile that has built-in sensor to alert the driver when tire pressure is low, for example, or other natural or man-made object that can be assigned as internal protocol address and is able to transfer data over a network. Okay, another important technology that can be utilized is artificial neural network. This is just like our brain, yeah, the nervous, our nerve. But this is the computer one, ANN. Among the aquaculture 4.0 technologies, AI is receiving an increasing interest. In a complex system of aquatic food production, AI deployment can happen many ways. It requires aligning the biological data with computers and then understanding how the system works for solving specific problem. Basically, this procedure involves what we call artificial neural network. ANN is a computational model, yeah, inspired by neural network of human nervous system. Like our brain lah, it mimics our brain, yeah. Whereas sense organ perceive stimuli that are transmitted through sensory nerve to the brain, then decide how to respond to stimuli and send the information through motor nerves to the effector organ to act accordingly. So this is the foundation of artificial intelligence, yeah, where flow of information happens through algorithmic pathways. So this is not our field, yeah. They are using a lot of algorithm in this technology. Okay, this is, let's have a look what is the artificial neural network, how it functions in general. ANN, like our brain, they have nodes, yeah, which in biology a term is neuron lah, if in our brain, but this is not the brain, this is the AI, the computer, the artificial intelligence, yeah. But the concept is like our brain. So it has different nodes where multiple nodes arranged in 3 layers. This is just the concept, yeah. The input, the hidden layer, and the output layer. So in this input, for example, if we relate it with our aquaculture subject, this is where we capture the data, the value from the source. For example, if you want to measure water quality, we use YSI meter, right? So when we want to measure DO, the pH, the temperature, and then that is the input. And then the hidden one is the AI-based device. This is the computer that process what has been given from the input. Logical calculation are performed by the hidden layer, which then triggers the command to the AI-based device. So this one here, a lot of algorithm, a lot of what do you call? Suddenly I forgot. A lot of things here, yeah. What they do, like I can't remember what I want to say. This is where these data are processed. Yeah, they are processing the data here by several, maybe formula, you know, and then only it will be passed to the output, whereby the output, for example, you are measuring water quality using your YSI, which is connected to your AI, your artificial intelligence, your computer here. When they transfer, let's say you already set here, yeah, your AI here have programs, yeah, computer programs that already have standard. Let's say DO must be 4, if it is below that or more than that, what will happen? Something like that. Or if pH is around 7 to maybe 8 or 7 to 6 point something to, there must be a range that is written. Yeah, written. The program has to be written here. If this less than that, what should be displayed in this output? Let's say this output is in your handphone to see your pond. This is, for example, you are measuring water quality inside the pond. You are at home looking at your handphone, and then when this translate here, or the reading of the DO is below 4, suddenly it will blink or produce alarm or something. So this is the output in the form of the message displayed by the system. So this is a basic concept how artificial neural network will works. Yeah. Okay, equipment digitization, precision control, and what is this? I can say edge computing. Intelligent aquaculture needs precise equipment control to achieve automatic operation of aquaculture system. Take the aeration equipment as example. You know aeration, right? In your tank, you will put aeration tube with the stone, and then you will have your tank aerated. In the traditional model, farmer must manually turn on or off the switch to control the air or the oxygen content in the water, because you know the aeration tube, we can adjust the button, whether you want to have it very strong or very mild or even very slow, depending on your fish stage, for example. This is our traditional model, right? We do it manually. But this, in the modern sensor era, farmers can remotely use computer or mobile phones to send commands to control the equipment, so that the actuators such as pump and aerator will be turned on and off automatically. For example, after receiving the input to the AI, the output appear in your handphone saying that the aerator suddenly off, for example, due to some reason. So you can control it from, remotely from home. You just switch it back, for example. So you don't have to go there. You don't have to be there. You don't have to be in your farm during Saturday, Sunday, for example. In latest development also, intelligent aquaculture can directly send the oxygen measurement to the system through the sensor, and the system can understand the dissolved oxygen in the water in real time. So it's real-time data, no delay. So this is the good thing about intelligent aquaculture system. So based on the collected data and the parameter threshold, the centralized controller can automatically turn on or off water pump or electronic valve or any other equipment that you want to monitor remotely. So it's very, very interesting. Okay, let's have a look at what is big data. We always hear about big data, cloud platform. I myself honestly not very familiar when it started, all these are IT terms, accurate monitoring, detection, optimal control of aquaculture are extremely difficult with its special object, complex environment, and many influencing factors. So the fundamental way to solve this problem is to combine big data technology with the cloud platform, and then process, analyze this large data that we produce and present the result. This big data and cloud platform technology is quite specific application in the field of aquaculture. So through acquisition, classification, processing, management, mining, and analysis of aquaculture data, so we can extract the whatever analysis out of the data, and then we will be able to decide as a owner, for example, so that we can achieve accurate, intelligent, and optimal responses in our business. Yeah, so big data and the cloud platform are mainly used for data collection. But it's reflect in the name lah. Big data mean used for data storage, data collection, data mining, and application, but related to aquaculture. Of course, there are a lot of other industry that using big data, right? But in aquaculture also, we can apply big data. Okay, let's move to the smart feeding system. This is one of the system that can be integrated with the technology that we have discussed just now. Sensor, ANN, all that can be applied in the smart feeding system. So in order to accurately control and judge the reasonable feeding time, improve the efficiency of feeding, machine vision technology can be used to obtain the feeding parameters of ingested fish to realize the accurate feeding of fish in aquaculture. So meaning to say we can use machine to observe our fish. You don't have to use your eye, but we can use machine to watch, to see our fish. That is another advantage, yeah, machine vision. Sonar, I'm sure you know about sonar technology. Sonar technology normally used to do imaging underwater. I think mungkin Bu Umi selalu buat bathymetry or whatever, what do you call, analysis under the water. You want to see the image, sonar is normally used. So sonar imaging technology has been also successfully used for fish monitoring. Normally fish farmers, I mean a big one going out with the boat to catch fish, they have this ultrasound, what do you call, sonar technology to say which area has a lot of fish for them to catch. Yeah. Swimming position of the fish reflects the hungry degree of the fish. So interesting, yeah. If we understand the behavior of the fish, once we have the data to show that certain position of the fish reflects hungry, so meaning we can create the feeding time or the demand feeder. We can install that demand feeder to the fish by understanding the behavior. So underwater acoustic sensor is also used to monitor the 3D movement trajectory of fish and decide whether to stop feeding or not according to the detected position. So this is how the system, the technology used. You have to have some parameter first, how to understand. Only we can develop the technology or the machine to observe, because maybe it's species specific. Maybe some species will have this kind of position when they are hungry and other species may not have that. So this is one of the thing that maybe becoming a challenge when they develop this smart feeding. It may not work in all species, but there is always adjustment can be made. Okay, let's have a look at the intelligent feeding system that can be implemented on multi-source data fusion. Okay, this is the, for example, cage, yeah, and then they have underwater camera, water quality sensor, and sonar sensor. yeah, which is connected to the multi-source data fusion. They are storing it here, the data. And then apart from that, they have this weather station on top, yeah, on top, or maybe on land also can. And then you have already fish growth model, a data that you derive from past study, for example, and coupled with meteorological data, you feed it here, and then fish foraging behavior using camera. And by having all these different set of data from different sources, this data fusion center will be able to tell what kind of feeding decision model that can be applied. For example, which feed formula is the best, how much to feed, what time. For example, if you using automatic, yeah, and then there is intelligent control algorithm involved in this system. And then only it goes to the feeder. This is the final product that was instructed by all this process. Yeah. So we already have fish model. There must be a model fish that you want to, that you need the data. And then the meteorological data, today is hot, rainy. And then what is the behavior based on the observation from the camera? This is the the CPU that processing all this after a program is provided inside. Okay, and then after it process, it come out, oh, you should choose this decision model A, for example, and it come out this one, going through. And for example, oh, today I feed them with diet with antioxidant because water is not good. I will not feed much today. We only feed in the morning, for example. Decision based on this. This is the one decide after the center of thinking here. Yeah. Okay, let's have a look at unmanned patrol system. Meaning you don't have to be there. No man, no human can should be there. You are using robot, in other words. So Petrol equipment in the intelligent fish farm includes unmanned Petrol system and robot fish. The Petrol equipment can realize the daily underwater management, video information collection, behavior monitoring of breeding objects, and of course, the ecological environment monitoring. So particularly in open pen sea cage aquaculture, 5G will be used for high throughput HD video transmission and monitoring that can well solve the problem of high cost and difficulty of optical cable laying. So meaning, let's say you want to observe not only in aquaculture, maybe on other purpose, like you want to monitor your marine park, protected marine park, you want to see whether any illegal fish bombing, illegal fish harvesting, we can use unmanned patrol system rather than you jeopardize your marine police to dive and observe if there any, you know, what do you call, illegal activity underwater. We can use this unmanned or robotic system. Okay, this is design of fish behavior monitoring and analysis platform. Fish behavior is actually a very important, what do you call, very important aspect that need to be studied as well. Fish behavior study, normally we have to use what do you call, computer vision, like in this case camera. So for example here, this is the fish tank or maybe whatever pond cage, you will apply your camera, the different angle with the light source, and then of course you can install the sonar probe inside, and then you can transform it into the vision acoustic signal data layer. You remember the 3 layer, the input layer, and then excuse me, and then you can have different type of images, still image or even the video or acoustic data. And then this is where the deep learning, signal enhancement, feature extraction, target segmentation, then only you go here, target tracking and behavior analysis. So this is suitable for behavioral study. For example, we need to understand first the behavior using different equipment. In this case, normally camera or sonar will be able to help you in understanding a behavior of certain fish species so that you can decide. Like the previous slide, we said that certain trajectory position of fish may indicate how hungry they are. But I said not all fish will have the same hungry movement, for example. So that is the purpose of fish behavior study or observation or monitoring before we can go to the next step of deciding this movement is reflecting very hungry, this position is medium hungry, or this position of fish is very full, not hungry at all. So you must understand this, you must have this data, then only you can do the processing here. Okay, biomass statistic. Let's say you have a very huge cages which house tons of fish. You want to see what is the statistic, what is the total of biomass that you have from time to time, because fish die, fish grow. So 1 week you may end up with less or more fish, or even 1 month is a huge difference already. So biomass statistic is very crucial to support the fish farmer decision because it involves food requirement, drug consumption misalnya, and then also you want to know the mortality. So biomass statistic is usually to use to collect subsample from the culture pond, weigh them, and finally calculate the biomass of the whole pond. This is what we are doing now, right? If you want to estimate what is the biomass of your pond, then we take sample because we cannot afford to use the whole fish in the pond to calculate the biomass. It's very stressful and time consuming and not that smart. Our approach is take some sample, then only we weigh, then we assume that is the total biomass. So this is actually has a great error, which is true. Fish doesn't grow the same growth rate. There may be some big one, smaller one. So it's not correct actually. Labor intensive, of course, to do the whole sampling for huge pond, huge cages will be very labor intensive and also time consuming, which will bring great stress also to the cultured fish. So with the development of this smart technology, sensor, computing, machine vision, then this can be done non-destructive way to estimate biomass. Some researchers published, this BRZ 2015, they estimated the mass or biomass of jade perch by 2D computer vision technique. So meaning a set of fish sample with different sizes were photographed out of the water. And then the image processing algorithm was used to extract the length, area, and contour information of the fish in the sequence photo. So if you students or even lecturer interested in working on a project like this, you cannot work alone if you only have your background in biology or related to aquaculture. You normally work with people from information technology, people from the mathematics department, or even the engineering school if you're interested in unmanned technology or robotic technology. We can't do this by ourselves because we are not trained to have this kind of what do you call fundamental or the basic like algorithm and how to how to utilize this technology in a very scientific way. So a linear model with area, for example, length and width as input variables and weight as output was constructed by regression analysis. And then single factor regression equation using fish area without considering fin tail can accurately determine the weight of jet perch. So this is example from a study whereby they estimate the biomass of the fish using computer vision, whereby you don't have to do it manually anymore. Enough with this video, taking photo, and then they do some mathematics. Yeah, then they can come out with a more accurate biomass estimation than what we used to do this method, right? We are using this method. Okay, smart technology can also be used in diagnosing fish diseases. This is very interesting. Yeah, traditional diagnostic method for disease mainly depend on our own eyes. Yeah, we do in our lab, take some sick fish, observe under microscope, things like that. Yeah, and then we determine the type, what are the disease, is it caused by bacteria, caused by virus or fungi or parasite, and then how severe it is based on the manually. So it is very quite slow, for example, and now we can utilize this machine vision, computer vision, instead our own eyes to detect, to handle, to recognize sick fish. There is one publication here, Barbado et al. 2014, published about using machine vision. After a healthy fish gets sick, it is usually accompanied by changes in the color and texture of the body surface. So the surface color of a healthy carp usually appears black and bright on the back, and the part near the belly is white with clear texture, while the surface color of the sick fish generally shows red bloodshot, swelling or plaque, and the surface texture of fish change significantly in the early stage of the disease. So meaning they are using colors, yeah, colors, and then what observed by the machine vision. Since different fish suffer from the same disease with different symptoms, the first step is studying fish diseases is to identify the type of fish by analyzing the sub-images of sick fish body and extracting its feature, including the color feature and texture, based on the statistical method and wavelength method. So meaning before you can come up with this, you must have this raw data first. Yeah, for the computer to decide this one is it because of disease or other thing. Meaning to say you must have some fundamental study first to have a classification. In this case, let's say the carp are based on the coloring. If they identify this color, turn into this color, turn into this color, maybe can be categorized as sick. This one, if turn like this, not sick. So actually computer is just a machine. You are the one, still the one who instruct them. You are the one feeding the computer with the information, what to divide, what to decide. So at the end of the day, the smart thing or the smart technology here is still the human. Yeah, not the computer actually. Computer is only a machine. We are the one who invented it with whatever input that you want. Okay, smart system is also can be used in harvesting. You know, when we harvest fish, we normally go down to our pond. We have to be wet, you know, with your net and everything, and it's not easy if you have many ponds or many cages. That is traditional harvesting. Yeah, but with the intelligent AI system, we can use the technology that we have discussed just now, the sonar, the underwater camera. So everything can be arranged in a way that you can have precision fishing, meaning I just want to harvest half of the amount of the pond today. So you can use this with the computer, with the help of computer. And then the participation of unmanned vehicles or ship in the transportation of aquatic product will greatly improve efficiency, meaning it's very fast. Yeah, let's say it's a very huge cage in the sea. You want to harvest your fish inside the ocean. So you can use these unmanned vehicles or even unmanned ships. So this will help to achieve the goal of very high efficiency and energy to reduce labor intensity of fishermen, because our target just now in my first slide is to produce more and more fish to feed the world. Our human population now is almost 7.9 billion or something. So how are we going to feed this many human? Through technology intensification. Yeah. So in this case, I read a paper that using smart harvesting for sea cucumber. You know how to culture sea cucumber, right? Sea cucumber is quite unique. Unlike fish, they are the grazer. They are on the bottom. They are depending on the substrate. They eat the debris, the substrate. So for sea cucumber, normally we do ranching. We just release them in the sea, a pen with the pen, you know, so that they will not escape. So for harvesting, someone already initiate the idea using a robot, uses Doppler GPS integrated with navigation, with the computer vision and mechanical servo drive technology to automatic pickup sea cucumber that is already mature or already reached the market size. Very, very interesting. And navigation system of sea cucumber catching robot is responsible for collecting the position information of underwater robot, meaning they know how to navigate the controls by the system. Okay, let's have a look at this chart. This is the key technologies in intelligent fish farm that can be used. What is the time now? Okay, I think after this we can stop for question and answer. Let's have a look at this slide. Pond type intelligent fish farm. The upper part is the pond. What can be done? What technology can be used? Water quality, weather sensor, equipment working condition sensor, so environment and equipment condition monitoring. You have these tools to get this data. And if you want to do monitoring or control or transporting, you can use this technology. Unmanned drone. Drone is widely used nowadays. Unmanned boat, unmanned vehicle for this purpose. And you can use intelligent aerator You remember we discussed about aeration system. Intelligent feeder, also we discussed just now about how to feed our fish without being there. So this is what you get, water quality data and feeding control. And of course, automatic fishing net and separator. So adult fish or harvest, meaning to say if you want to harvest certain size only, they will know how to separate. So these are the technology that can use in the pond. How about land-based type intelligent fish farm, meaning in the cage hatchery? Yeah, RAS. I'm sure everyone here know what is RAS for water treatment. Water quality sensor, equipment working conditions sensor, high density. Is it high density for HD? I think so. High HD camera, environment and equipment conditioning monitoring. Yeah, meaning the condition of your tank lah, your fish stock, how is the water, how is the condition. And then here also the same with pond. You can also use the same technology for tank. Fish pump and separator also the same, because if you use tank, normally you need to pump your water from the what do you call, your reservoir. Yeah, and unmanned vehicle also can be used in the land-based farm. Okay, how about in the cage? In the cage also the same, water quality sensor. You can get weather sensor or sonar, Doppler sensor, underwater camera, robot fish. This is for 3D environmental monitoring. If you use unmanned drone, unmanned boat, or underwater operation robot, you can use it to get data or to help you monitor your stock or to help you transportation like this. Intelligent feeder, emergency control system, automatic fish net and separator also will give you the same data like in the land-based or pond intelligence system. How about marine ranch, like sea cucumber ranching, for example? You can use the same technology, water quality, weather sensor, sonar. I'm not sure what is SRS. Doppler sensor, underwater camera, robot fish. This also will provide you with environmental monitoring. The same thing with unmanned drone, unmanned boat, underwater operation boat, robot. This also give you some sort of control or transportation. So for feeding, harvesting, and emergency treatment, you can use the same technology like above. And for fish domestication, it is also available in terms of system, meaning to say you want to recruit new species for aquaculture, but of course they need to be domesticated first. They need to be trained to the captivity. You know, they're not used to pellet. They use with trash fish. You need to train them slowly. So there is also possible for us to use the technology. Yeah. So I think I stop here for maybe question and answer.
Yeah. We start to Q&A session, Prof.
Yeah, no,
Yeah.
I mean, okay, we can stop for a while. Prof. Rosita.
Okay.
Yeah, actually, it's still about half an hour later, but it's okay if.
Okay.
If yeah, Ibu Febri, if there's already one question from Prof. Sukoso.
Okay. All right. Okay.
In the chat, would you mind just take for a while?
Yeah. Okay. When all work is done with robotic system automation, there is a reduction in the role of labor. human resource, then what should be prepared for human resources to face this, and what is the role of education and higher education in the future to face for? Very true. This question, thank you so much. Meaning more and more labor or human resource in the farm, for example, is no longer needed because being replaced by robot, for example. I agree with you, and we have to start thinking on how to overcome, on how to adapt with these challenges. One of the most what do you call top courses right now is IT, computer science. This is one of the most, because this is the future actually. So many when we rank what are the courses, last time maybe, you know, like engineering, medical, things like that. Now no, it's IT based. It's information technology, computer science, data science. These are the courses that is very on the top list in the world actually. So meaning to say people moving towards, you know, choosing that kind of career because of this what do you call, the change in this technology landscape all over the world. But I think not all people should, you know, just concentrate in one kind of occupation, which is in the IT system. There must be someone else who's doing other job, things like that. If what happened if even our cleaner, you know, we don't need the human cleaner anymore. So yeah, this is a very challenging I think challenging things that we are facing, but at the same time we are still moving towards that. So I don't know how, there must be some adaptation towards this. And in our university, most of the program that doesn't have student, you know, they have numbers, limit numbers. If student less than 15 per year, we are requested to close the program because no one wanted to enroll. And normally aquaculture, you know, sometimes not so many interested student want to enroll. Also, we are feeling very nervous because the ministry don't like it if you know there is no intake. So things like this that the government, I think, should think beyond this what do you call interest of the student. We also have to think about the interest of the country, the interest of the world. So I don't really have the exact question answer for this one, but I do share the same view or the same worry as you on this one. But like it or not, we also have to understand what is going on. Since I was given this topic, so I have to share
Bro, I think this condition is kind of paradox, isn't it, Professor?
Yes.
In one way we have to had in the future the challenge that everything becomes ITs become so robotic and so on by internet. But on the other hand, we still have so many like labor or human resources that we have to think about, that we cannot just leave it. So I think I mean the authorities should have a very wise you know, we are so that this country or the situation would not make us like behind the schedule, but also not really humanitarian. Isn't that
being replaced by robot?
Yeah,
I don't know.
because
Maybe we will end up working, making robots. Maybe that is the the job opportunity available, like making chips, in the
yeah,
factory.
switching jobs, isn't it,
Yes,
Professor?
yes.
Instead of everybody become farmer, probably now they have to work
Yeah.
in the industrial sector, probably to support this kind of technology or something. That might be also an idea.
Yeah.
Yeah. Here's our professor, Prof. Sukoso. Do you have
Oh,
some remark, or please unmute yourself?
maybe
Prof.
Prof.
Rosita.
also wanted to share also his view on how are we going to, face this this technology at the same time, not to neglect our own, what do you call, humanity kind of
Yeah,
aspect. Yeah.
humanity. Yes, humanity. Yeah.
Okay, thank you, Prof. So really, it's sometimes I also think about my idea with the future of our Earth capacity, and increasing the population and also the destruction, maybe eruption, something like that, for our ecosystem. Yeah, it's good for maybe for study the future. Maybe in based on your opinion, any idea how to design our curriculum, to mix in order to anticipate with the 4.0, because it's basically based on the computerizing, robotic, like IoT and so on. Okay, thank you. Maybe it can be our discussion in the next for our meeting in Fisheries Faculty of Brawijaya University. Thank you for your attention.
Prof. Sukoso.
Thank you.
In
Yeah.
University Malaysia Sabah, we are encouraged to in our curriculum, we are encouraged to embed, this what do you call IR 4.0 element in the subject. So if prior to this we don't have any subject called smart aquaculture, now we have to introduce this one subject in the curriculum, in the so that the undergraduate the coursework. So this is the early early adaptation that the university is doing. So even now we not only in aquaculture but also in other programs that they want us to embed this component of IT, of IR 4.0. Even like agriculture also, they are now having like precision agriculture subject, things like that. So this is the starting, I think, so that everyone will be aware of what is the world is having, the current technology. But like us, we are biologists, sometimes it's also difficult for us to to involve
To
in this
adapt.
one. Yeah, to adapt. And we are depending on, like UMS, we are having faculty of computering and information technology. So I have a new research grant on what do you call feeding behavior using smart technology, a demand feeder or for grouper. This one I have to work with the engineering lecturer and also this computing lecturer. Otherwise, I don't know how to develop the robot or anything like that, the machine thing, everything. So I handle the biology part, and then the rest are handled by the according to the expertise. So this is how we can work in the university. In the curriculum also, we need the expertise from other faculties to come to our aquaculture faculty, something like that we have to to share the expertise across the faculty and institute. I think in Brawijaya also you also have this computering faculty, no?
Yeah, we do have like IT, computer science faculty. Yes, we do have.
That will help a lot in designing your curriculum so that we remain relevant, because if we also did not integrate this IT part, so we become so-called left behind, right? The technology out there, things like so it's very difficult for us to what do you call to not
to catch up with the new era or like period of time or phase.
So something like that what we are doing in our curriculum.
Okay, there will be still more time to discuss it in the faculty when you have your our seminar, national or international seminar later.
All right.
So, Prof, Rosita, probably from other colleague, do you have any other questions? Or if you don't, please try to write it down on the chat. Then later we will read it for you. If not, then Prof. Rosita, you may continue until for probably an hour, and then we will have another session, small session for question and answer again, and you can continue until finish later.
All right, thank you.
Yeah.
Okay. We continue with more words here. Main steps in modern aquaculture system. Okay, just to summarize here, we need to improve our accuracy, precision, and repeatability in the farming process. So we need to facilitate a greater degree of automation or inbuilt controls in regular monitoring of the farming system. We need to provide a dependable decision support system characterized by a computerized program for collecting, analyzing data, synthesizing information that can be used to solve the problem by algorithms and human intervention, or both algorithm and human intervention. So we will reduce, like what we discussed, dependency on manual labor and subject assessment. Okay, this is what the key steps that we are discussing just now. The observation, the sensor, observe, and then interpret, and then we decide based what is the interpretation, which is also we are the one who created how to interpret the data from the observation, and we decide here, and then the action. So overall objective is to improve productivity, to resource efficiency, and of course sustainability and economic benefits. So the fish stock in cultural facilities should be able to perform and express its biological activity. So the bio responses need to be observed, step 1, this one, and then interpreted to for assessment, and then only we can make decision and action. Okay, just to share with you a model of smart aquaculture system. Okay, this is the tank. Sorry, cages, submersible cages. We have our what do you call camera, the thermometer icon here, meaning this is the gadget to measure temperature. And then we have underwater drone, and then underwater feeding device, this bin here containing feeds, and then this is also connected to the air compressor. And then we have the computer here to process whatever this camera, the sensor, the underwater drone provide the input. So in the control point, and then we have tubes to supply feed whatsoever. And then through the satellite internet, we transfer everything to the smartphone. And then you can decide, you can observe whether you want to continue feeding, you want to stop, or anything abnormal, what you get from the gadget here. So the same concept. So the smart aquaculture IoT system, it is more or less the same. Yeah, everything is the same. But sometimes, like I said in the previous, previous slide, IoT, smart aquaculture, this is used interchangeably. So there may be, for the expert in this field, they know what is the difference. I'll share you later on. Yeah, I have the definition of all this technology. Same thing with this one on the water quality sensor. This one is smartphone based, you see. And then this is the probe, right? When we measure water quality. So these are the data, the interface that they are collecting, synthesize, and then decide based on the 3 input layer concept. This is just to show you the example that people doing out there. Yeah, it's already in the market. You can see this one. You try, go to your handphone, go to your app store. You will see this hydrocolor. So meaning to say, if you go to the pond, for example, you can check the turbidity of the pond just using your handphone. After you install these apps, this hydrocolor, I think it's free if I'm not mistaken. You may check your app store. Hang on, yeah, I check my app store, hydrocolor. Is it free? Yeah, I think it's free. You can install this. It's free of charge if because I didn't see any amount of price here. So you just use this and you can get some information like turbidity. Not much lah. I don't think they have some other parameters. This is what I can see, the turbidity especially. Hydrocolor is a water quality application. Use smartphone to determine reflectance of natural water bodies. So you can estimate water turbidity or suspended solid also. Yeah, these two. So you may want to try, a student, you can try and download it and then see what is the turbidity, and you can compare with your Sachidest, the one we used to measure turbidity in our pond, in our system. See whether or not they are giving you the same data or a different reading. Will be interesting. I think for undergraduate student, you can come out with one project for your final year project thesis. Maybe just comparing how close, what is the accuracy of this hydrocolor versus your Sachidest, for example. Suddenly, I just got idea when I see this. I didn't think about it actually. So interesting. People are developing this kind of apps, yeah, and I think from here later on people will come out with more advanced apps, yeah. Maybe the one can measure, I don't know, the chlorophyll, the nutrient, this of oxygen or things like that. But this is what available at the moment. Oh, I want to share with you this one. The gadget.
If you wear glasses or contacts, you must see this. An award-winning doctor reveals an...
As the world's population grows and becomes more health conscious, so does the demand for healthy and nutritious fish and seafood. Current aquaculture practices simply cannot keep up with the ever-increasing demand. opening a window of opportunity for a sustainable alternative. Recirculating Aquaculture System Technology, or RAS. In RAS, fish are grown inland in a closed system. These facilities provide an industrial, controlled, safe, and traceable environment, free from antibiotics, chemicals, and hormones. RAS technology can be anywhere in the world, enabling the local production of fish and seafood close to market with a significantly reduced carbon footprint. RAS enables us to grow tropical fish in Arctic climates and cold water species in the desert. RAS also allows for continuous stocking, production, and harvest all year round. Backed by 30 years of experience in the aquaculture industry, Aquamoth has developed the world's most advanced RAS technology. Aquamoth's systems are extremely flexible and scalable, accommodating a variety of fish species and production capacities. Promoting sustainability, the technology uses approximately 1/3 of the electricity used by competing systems and filters almost 100% of the water with stable and optimal water parameters, offering complete control over the entire production process. The Aquamoth platform creates an optimum water flow speed and stress-free environment. With facilities operating successfully around the world and many others in the works, Aquamoth is applying its know-how and vision to create the smart, sustainable, and efficient aquaculture systems of the future today.
This is because the next topic is on recirculating aquaculture system. Just want to share you the concept of RAS, which I think everyone knows on the benefit, what is the purpose of RAS, yeah? Because in terms of, again, it has greatly reduced labor demand and production is often greatly increased. And of course, we know that recycling water will help us to conserve water and also reduce the waste management. Oh, hang on, what is this? Okay, I want to show you, hang on. Okay, I understand. This is a very interesting and latest, yeah, consider very latest news that I must share with you. It happens in our nearby neighbor, Singapore.
A $4 million smart fish farm expected to produce about 350 tons of fish annually was officially launched today, opening the door to better food security for Singapore. The floating farm uses artificial intelligence and video analytics to monitor fish and detect early signs of disease. Vanessa Lim with more.
When fully operational in 2021, this 3,000 square meter farm off Pasir will be able to produce 350 tons of fish a year. That's about 6% of the total amount of fish produced in Singapore in 2018. It's using a closed containment system to isolate the fish from the ocean, to guard against threats like algae blooms and oil spills. And sensors monitor water quality as well as oxygen and acidity levels to make operations more efficient. This is the heart of the farm's operations. Now, this system over here uses artificial intelligence to monitor fish movements, and also it's programmed to detect early signs of a disease like white spots in a fish. Now, also looks at the behavior of fish during feeding to determine when to stop, and this prevents overfeeding. Now, all this helps to boost productivity and also reduce fish mortality rates. The company behind the farm says automating processes and going high-tech could also attract more to join the trade.
We want to offer jobs more towards process design, towards engineering, towards artificial intelligence. These are things that young people want to work with. And this is important if the fish farming community wants to move forward and engage the next generation.
And this is key, with the country looking to ramp up local production to meet 30% of its nutritional needs by 2030.
Our food production methods and technology must therefore adapt and improve. In the face of challenges posed by climate change, our food production must not only be high yielding, it must also be climate resilient and resource efficient.
Food security will be a focus at the upcoming Committee of Supply debate.
Okay. So very interesting.
Sebagai ibu, kita mahukan yang terbaik untuk perkembangan anak-anak kita. Nespread salah satu.
Okay. That was in Singapore. Yeah, it was launched in 2020 with high-tech solution. This is, I think, one of the first one in the world, a smart floating fish in Singapore sometime last year, 2020 February. So this, if you can see, they were using barge. Yeah, the tank was positioned on a barge whereby they equipped this facility with latest technology. They have underwater cameras monitor. They are culturing barramundi, which is our ASEAN sea bass, and red snapper in the tanks. Yeah, it can hold like 1.8 million liters of water each. So cameras are part of the digital system in the monitor for feed, for growth, and of course the survival rate. And they also use artificial intelligence to make increasingly precise analysis and prediction of the fish. So this is actually using RAS, Recirculating Aquaculture System. If you can see, it floats on the sea. Yeah, they are using actually water from the surrounding by using RAS system. They treat the water. So, and then this is a closed containment system, requires only 5 to 10% top up each day. So this how efficient the system that they're using. So inside it looks like this. Yeah. So the water used for top up is taken from the surrounding sea. Then they filter the water and sterilize, yeah? And then, I mean, they're using UV, ozone, things like that. And then they also have Sonar, a solar panel on their roofing and batteries on the farm, which provide bulk of its energy needs. So the concept is sustainable farming, apart from the smart farming, because they're using solar to reduce energy consumption from electricity, while the rest of the rest of the equipment are supplied by diesel. So farm is about 100 by 27 meters, and then it expects to yield 250 tons of fish per year. So very efficient, even though it's not that huge in size. So recirculating system is one of the what do you call technology that is already practiced for quite some time, right? It's not new thing, but up to now RAS is still considered a very what do you call a very viable and useful technology to be used during this IR 4.0 era. So with all the system in place, the farm said they only require half the amount of manpower previously needed, meaning they cut off the workers, and the farm costs only just over 3 million Sing dollar, which is quite cheap actually. We are now developing one hatchery in our university, so this will be the third hatchery that we have. We spend like 12 million ringgit. 3 million Sing dollar is about 10 million, I think. Yeah, about 10 million. So it's not that expensive for a hatchery cost. So this is another, what do you call, approach that the industry is looking nowadays. Oops, what is this? This is the water quality part.
With a growing population comes a growing need to feed the world. As space on our planet is limited, we have to find new ways to increase the harvest and yield to keep food affordable. With more than 1 billion people relying on seafood as their main source of protein, aquaculture is a vital part in ensuring a steady supply. For shrimp farmers, maintaining the water quality, keeping stock healthy, as well as determining the correct amount of feed is vital for business success. Bad water quality and inaccurate feeding can lead to significant financial losses by putting health and yield of the stock at risk. Making informed decisions based on reliable data is critical. To support farmers, Bosch has developed AquaEasy. AquaEasy is a smart IoT-enabled aquaculture solution that provides an end-to-end solution for shrimp farmers. The solution relies on 3 main components: sensors, software, and analytics. The sensor component ensures accurate, fast, and reliable measurement of multiple water quality parameters. Through the cloud connection and artificial intelligence, collected data is analyzed in real time to provide insights and recommendations for harvest prediction, feeding optimization, water quality management, and remote monitoring, helping you to make better decisions, lower your operating costs, and significantly increase your yield. Bosch, invent.
So this is another example of the industry offering out there, different technology they are offering, meaning to say they the technology is ready to be used, up to the industry whether they want to take it or not. So this is how the industry IR 4.0 evolved for the past few years, even though we know IR 4.0, the first time they introduced back in, I think, 2011, slowly, and only in 9-10 years time now, yeah, this is how they evolve and, you know, invented new things in terms of our industry, aquaculture. Okay. This is just to share with you good and bad practices in aquaculture that require our attention when we want to, you know, utilize whatever technology that is available nowadays. We have to, we should not miss these practices or points when we want to adopt new technology, be it IoT or computer vision, you name it, but you have to come back to the core of the good practices, which is spelled out here. Number 1, it should be environment friendly, meaning whatever technology that you want to adopt, if it's not environmental friendly, then we should forget about that technology that didn't support the environment. It will not be sustainable for long term. So these are number 1 practice that require attention. Number 2 is spare animals from the stress of captivity, cruelty, and sacrifice. So meaning to say the well-being of the cultured fish should be also the center of our attention. We don't want out of, you know, profit oriented, we culture fish over stock, over a very high density, whereby this is, you know, will be having issue in terms of, like, you know, the what do you call, activists will be not happy, for example. Of course, in terms of animal ethics also, we don't want to crowd the fish up to the level that they are under stress. So these are the things, the practice that should be remember whenever we want to adopt technology. We want to avoid this. And number 3, free of seafood poisoning risk. Of course, this is another major issue, food safety. Not only food security, food has to be safe also for us to consume. We don't want, we produce abundance of fish or shrimp, but there is a risk of toxic material that will be end up in human system. So this is another practice that should be always in our mind as our a producer or aquaculture practitioner. Number 4, free of zoonotic infection concern. This is related to the disease outbreak. We have to consider this as well. Easy to manipulate nutritional and organoleptic quality by culinary processing, meaning to say this day we are trying our best to replace fish meal, for example, or even fish oil in the diet of fish because of the price. The price of fish meal is very high, and then the approach is not sustainable, things like that. So we tend to use soybean meal and all that. So it somehow affect the quality of the product, the fish. So if that product is easily to be manipulated nutritionally, is good. Let's say after we feed the fish with the soybean meal or the palm oil based diet, before harvest we change back the profile, the nutritional profile. We feed them with fish oil based diet, for example. So when we harvest that product, they become a nutritious, they contain omega-3, for example, rather than they contain only omega-6 because of the diet doesn't supply omega-3. So the product should be easy to manipulate nutritionally, and of course organoleptic quality by culinary processing just simply means that even though the fish may be lacking some, I don't know, some nutrient, but with the culinary tactic that it is acceptable by many consumers. So these are also should be taken into consideration. Number 6 is easy to develop into functional food. The term functional food, right? So meaning whatever aquaculture product that we produce, it should be able to be developed into a useful product, in this case, the functional product. Number 7, produce according to the demand and save the product from loss in case of supply chain disruption. So this is quite true during this pandemic. Yeah, we learned a lot from the pandemic, whereby there is one farm that I know, the local farm here in my place, that they are producing fish, but during pandemic, a lot of fish, but they don't have buyer. They cannot sell the fish. So what happened? They need to, lucky they have idea straight away. They turn the fish into like value added product. They do some what do you call high end kind of ikan masin, salted fish, but they make it like it's a high end salted fish, because this is ASEAN sea bass. So they pack it nicely, they pack it in vacuum packing, they produce a very nice box of fish, like you can make it as a gift to your friend. So this is how they adapt through the situation. So it's very, very important also to plan, to think about marketing strategy. If you have this amount of fish and suddenly you cannot sell, you will lose a lot. You will end up what do you call, maybe closing your business because of this supply chain disruption. So the product must be what do you call, must be adaptable enough for us to, don't have to sell it live, but we can make it, turn it into other product that can be sell when the condition permits when there is no more pandemic, for example. Okay, one bad practice that we highlight here is counterfeit food product containing false claims on functional properties or even containing harmful substances. So this is important, yeah. If you want to grow big, it's very important for us to, I think you need to be transparent. You need to be very, very honest when you do your business for not claiming things that the product has in terms of, for example, functional properties or nutritional value that you said, oh, this one has this and that. Last time you remember when the seaweed first come in the market, people sell this collagen seaweed, something like that. We want to sell this collagen seaweed, is good for your skin, blah, blah. Many people, you know, believe that, but this is a kind of false claim because we know that seaweed doesn't produce collagen. So this kind of things should be avoided. That's why it's important to have knowledge, yeah, in this, what do you call, in this field before they are going out there to claim certain things of the product. Okay, what are the constraints and options? The main factors constraining technology intensification are, first, reluctant to change, especially the small enterprise, small farmers, because I think it's very difficult for them also because technology is not cheap. So I think one of the factors making them so reluctant is due to the cost also. Investment risk that weighs heavily in the decision making in large scale enterprise. It's quite true. The technology that we've discussed is very, very promising, but at the same time, it's not risk-free. It's high risk, also high returns. Aquaculture is a business that high risk, high return. So this is the investment risk that they need to weigh. Yeah, they need to consider heavily in the decision making. So these are one of the constraints in this industry when they want to adopt like IoT, like unmanned machine, something like that. So the decision-making part is normally one of the constraint. Shortage of skilled human resources, which is quite true. In our country, unlike what do you call, the countries like Japan, like US, or in the Europe, they have, when they have this farm, normally farms are run by those educated human resource. I still remember one of the what do you call, the person running a hatchery in Australia in my university last year is a degree holder. Unlike in our place, normally those working as labor, you know, are not educated at all. So skill human resource is important, but of course, skill doesn't mean you have to go to university. Through experience also you can be very skillful also, but this will take times also. So combination with university education and real experience are important to me. Okay, 3, lack of gainful employment opportunities for graduates who have the knowledge for high-tech operation. So in our place, there's not still not many, I'm not sure in Indonesia, but in Malaysia, still lacking opportunities for graduates to gain employment, yeah, to get job. It's not easy. Okay, the prospect for aquaculture sector to transform would be brighter with the realization of the inability of the current system to meet the fish production targets and when significant benefits from technology-intensive system become apparent. Another reason which will influence market perception will be when the consumers demand to know the methods of growing food and tracer technology gains a foothold. There are three directions for the future growth of aquaculture industry. First, optimization of existing culture system. We optimize our system. Genetic modification is also suggested, but of course can be controversial. And new species as future food. So these three directions have been discussed. We published one paper on this one actually. Yeah, how do we what is the direction for future growth of aquaculture industry? Okay, let's have a look at our first recommendation, which is on optimization of existing culture system, meaning we still can use our whatever we have now, whatever technology we have now, but we need to optimize it. Okay, aquaculture industry has a track record of improving the rearing system, meaning to say from time to time, we improve it. Knowledge and technological intervention have always supported the production and the diversification of aquaculture. As a result, aquaculture has grown at a rate of 7.529% annually and emerged as the fastest developing food sector. This is quite true about aquaculture. Yeah, we are the fastest growing food sector in the world. Established aquaculture system, such as those for high value finfish like grouper, sea bass, shrimp, and crab, have been increasing production to meet the demand in the face of stabilization or declining capture fisheries using existing infra. So this system requires input of new knowledge for meeting the requirement of sustainable development. Okay, let's have a look at genetic modification. Certain genetic modification have demonstrated a quantum increase in fish growth. Yeah, we cannot deny also, you know, like genetic engineering has been contributing a lot to agriculture, for example. Yeah, even though there's so much controversial when it's come to GMO, soybean GMO or anything GMO is not that, you know, popular in the world markets because of certain different concern by different people. Growth rate of transgenic fish can be increased by 400 to 600% while simultaneously reducing the feed input. Genetically engineered tilapia has been reported to put on weight 300%. Yeah, tilapia is one of the species that went through genetic modification lately. Genetically modified Atlantic salmon, for example, attains market size in the half the time compared to the conventional one that takes 32 to 36 months. So meaning to say, genetic plays a role in improving the performance of aquaculture species, like it or not. Okay, producing genetically modified organism, like I said, GMO, is a controversial topic. Although market forces see benefits, but conservation biologists normally are concerned about the ecosystem implication of GMOs in case of their entry to the wild. Consumer perception about GMO is divided between acceptance and rejection. Resolution of this issue will take time, I'm sure. And future food security challenges and climate change also an issue that will be we have to face. Adaptation will probably shape the cost or benefit analysis of genetically modified fish. For now, aquaculture can remain focused on the non-controversial methods of production. In our hatchery, we successfully produce hybrid grouper between tiger grouper and giant grouper. This hybrid has been commercialized throughout Asia Pacific. The China, Taiwan now is the one of the biggest producer after China, even though we started it first back in 2006, I think. So even though it is not really genetically modified organism, we don't regard hybrid fish is genetically modified. This is the interspecific hybridization between tiger grouper and giant grouper. There is no, it's unlike the intraspecific hybridization that like in the tilapia, but the one we produce is, we don't regard it as GMO. So the benefit of hybridization is quite significant in the case of this grouper hybrid that we produce, because the growth is quite fast, and then they are also quite, what do you call, resistant to disease. And when it comes to the feeding performance, when I feed the tiger grouper with the soybean, the plant-based feed, normally they rather die, you know, sometimes than eating the feed without a fish component in it. But when I do the same to hybrid grouper, they are not that fussy. They are taking whatever you give, you know, straight away without much what do you call, issues. So the hybridization trait, the advantage of having hybridization really shows in this particular hybrid that we produce. So genetic definitely has some contribution in terms of increasing the fish production. So that's why we put this genetic issue as one of the things that we can consider in terms of intensifying our fish production for our future. Although I myself don't really, you know, I'm not a big fan of GMO myself, but to me, hybridization between the interspecific one is not harmful, because in the wild also hybridization occur naturally. So this kind of concept, I think, can be considered by the farmers, but of course we have to be careful, definitely not to release our cultured fish to the wild, so that, you know, the concern like it will interrupt the ecosystem, the in the wild will not be become an issue. Okay, we are also discussing or proposing about selecting new species in this IR 4.0, because the whole idea of intensification of technology is about is dependent on the species itself. So we have to be very careful when we are selecting the species. So species should be adaptability very high, and meaning to say they are tolerant to captivity, because from the wild they freely swim everywhere they can, but in the tank they have limitations. So they need to be a species that can adapt easily, and preferably at high stocking density, but of course, not to the level that it will put stress to the fish. High rate of survival and fast growth are another important criteria that we are always considered when we choose new species. Definitely, acceptance of artificial diets or formulated diets and nutritional efficiency are also critical for us to consider, because some fish are extremely fussy. They are not willing to eat the artificial feed or the formulated feed. They are very, what do you call, even you train also, it takes some time. Ability of physiological system to accept interventions aimed at developing farm fish as functional food. Resilient to the effects of climate change and other external drivers. In the case of hybrid groupers that we produce in our hatchery, we have tried some tests in terms of the resilient to the climate change. We use stress test using what do you call acid. Yeah, we do some acidification test, pH test to see, and it is proven that hybrid grouper is quite resilient to this effect. So this is the kind of the criteria of species that we want in this changing climate. You know, we have global warming issue. We will have issue if you culture fish that is so, you know, not resilient, you know, fish that are very susceptible to disease, things like that. Amenability to farming in compliance with sustainability requirement. Think tomorrow, tomorrow I will talk about sustainable aquaculture. So we'll discuss more about what is sustainability concept or requirements. And then last, consumer preference and marketability. Of course, this is also another point that we need to consider. Because if we don't have buyer, then there is no point. If people don't like to eat that kind of fish, then how to market your fish? So we, on top of fast growth, you know, adaptability, easy to eat this kind of artificial food, we must also consider the preference of our consumer. If, let's say, our consumer, it happened they don't like freshwater fish, then we don't choose freshwater fish. Vice versa. Okay, what are the advantages of new species? Aquaculture industry can make a fresh start without the need for replacing the existing expensive culture infrastructure. Culture system for the new species can be designed in response to prevailing challenges, leveraging of past experience, and new system could offer scope for disruptive innovation, green tech, potential for developing into functional seafood system through bioencapsulation of diets or other means. So these are the advantage. Okay. What time we open for question answer, Bu Umi? It's 11 on my time, or I can continue. Bu Umi?
You still mute, Bu Umi.
Sorry. If you want to have a drink for a while.
Okay. So
now we can
take 10 minutes.
Yeah, sure. We can open on question and session right now, so you can little bit have a rest or something.
Okay, thanks.
Okay. Probably another 5 minutes. You want to rest for 5 minutes, Prof. Rosita?
Okay, all right.
Sorry. Wow. Yeah, actually we have to have a break in the long session like this. I will just mention it to the committee later. So then we have a break for 10 minutes or something. Then you can have rest for okay, dear participants, I guess we will have a break for 5 minutes and then continue with the question and answer session for about 15 minutes, and then we will continue the lecture again. So if you have question, please write down in the chat or otherwise raise your hands. Then later you can deliver your own questions. Okay. Will I see any raised hand? Okay, no raised hands. Okay, dear students, no questions? It's very interesting topic actually. Yeah. If I can say, yeah, okay, thank you. Thank you. I see one raised hand. Okay, we just have wait for 2 minutes, okay? And later we can deliver your questions. Yeah, for other students, actually, this the lecture today is about the fourth, what you call it, the fourth technology, revolution technology. Oh, hang on. Yeah. This is very futuristic for our condition at the moment, you know, like in aquacultural technology at the moment. It is very futuristic, which is, yeah, as I said before, it is paradox because we are a country with so many populations that we have to optimize their roles in this sustainable development. But we are faced with the challenge of the world that we have to face the period of time, the industrial 4.0 already. Ready or not ready, we have to face this challenge. So I think as academician, you are educated people, I think your thought, your point of view will be very important so that you are understand what we are facing today, our country face today. So this is the time in this kind of moment or event, you can express your point of view, your thought, I suppose. So the students, S1 or S2, just elaborate your thought, your thinking, and don't worry if you want to mention it in Indonesia, we will translate it for you. Otherwise, Prof. Rosita will also be able to answer it in Bahasa Melayu atau Bahasa Indonesia. Okay, Prof. Rosita, are you ready with the question and answer session?
Okay, I'm back.
Thank you so much.
Yeah.
Sorry.
Okay. Yeah, I saw a question. We have question from Mr. Iko Waluyo.
Yeah, yes.
Okay. Question are, in starting research on IoT in fish processing, what should we learn first to have a good understanding of IoT and their application in fish processing? Second, based on your experiences, in what area that should put in priority in applying IoT in fish processing? I think the question is almost the same, number 1 and 2.
Yeah.
I'll try my best to answer. Yeah, I may not be able to give you a very detailed answer because I also not really involved in depth in the research of IoT. Yeah. Most of my involvement is more to the concept, the idea, you know, the conceptual level, not into the very deep. I just started the project this year. We haven't got the students, so it's not really started yet. But based on our what do you call what we learn, what we know from available literature for fish processing, I think this will involve like packaging, right? After you let's say you want to sell your what do you call whatever fish yang quite big, let's say tuna or cobia, you want to do the fish processing, you must know your fish first. Yeah, what kind of I don't know, the tissue, the muscle they have, is it very soft kind of muscle? Because when you said processing, I'm not sure what exactly you mean by that. You want to process become what? Or is it packaging? Because if packaging, for example, your system will have receiving areas, whether you want to freeze them, to cut the flesh you want to sell in a chunk form, or you want to process into value-added product. I'm not sure what do you mean by that, but definitely you need to understand the quality of your fish or your product before you can decide into the fish processing. For example, the flesh is very soft, maybe it's not suitable to cut in such certain way, something like that, that you need to set the parameter. So you must have at least knowledge about their properties. Let's say, oh, this fish contains very high lipid, for example, or if we process it this way, in 1 week, it will be some oxidation happening, which is not good for the shelf life. When you sell your fish, it will deteriorate the quality. So understanding on the basic of the fish itself is, I think, very important. That is the first priority that you must know before you apply any technology, not only IoT. Understanding the subject. Yeah, you must know what is the what do you call criteria of your subject, your fish containing what kind of nutrient. Is it very white meat, the red meat, things like that, you must know, because it will influence the way you cut them, the way you process them. So all this has to be taken care, meaning to say, you know, your product, they are grown in, for example, let's say your fish is grown in pond, which is sometimes you know, produce muddy smell, you know, not very pleasant smell. So all this you must understand. Where are they grown prior to your processing plant? You must, there must be a traceability record. What are they feeding in the farm? You must know this basic information, whether they are fed by, for example, trash fish, or a feed that is based on soybean alone or something like that, that will alter the taste of the fish itself. So you must know the subject. That is my answer. Yeah.
Prof. Rosita, for your information, Mr. Eko Waluyo is one of the lecturer in I suppose he is as the secretary in the processing departments in our faculty.
Nice meeting you, Mr. Eko.
Yeah.
You know
Thank you so
better
much,
than me.
Professor.
You know better than me since this is your your field.
Yeah. Okay,
Okay.
Professor, there's another
Thank you so much,
question.
Professor and Bu Umi. Thank you.
Yeah, thank you, Pak Eko Waluyo.
Sami-sami Bu Materun.
Yeah. So the second question is probably from Aulia first, who raised hands. Aulia, would you mind seeing your questions?
Yes. Can you hear me?
Yeah, I can.
Yeah.
Yeah, okay.
Hello, Miss Rosita. It's very pleased to meet you.
Yeah, same here.
So it's a very interesting subject. And as a matter of fact, in Indonesia, we have some startup company that focus on IoT for aquaculture. Actually, yeah, it's a very hot business for a startup to do the IoT for the aquaculture. But one thing that I am interested about from your presentation is that aquaculture on Singapore. You mentioned they using AI in well, also with the IoT, but also AI. But I wonder if maybe you have some knowledge about it, how the AI works actually. Is they fix themselves, or I mean, like, in case the water quality getting low, and then the AI try to analyze themselves, and then they use the devices to control the water quality, or is it has to be a human, because for the IoT that applied in Indonesia from the startup company, we only get the result from through our smartphone, and then we have to fix it ourselves. Regarding this Singapore, or do you have any experience? Is it they fix it themselves, or still using a human resource?
Okay, I don't have exactly the details on their system, yeah, because I got this information also from the internet, from news, and then also from some website, including World Aquaculture Society. But they do they engage expert in this field, in their business. So they have all experts there. So it's taken care of by the expert that they are hiring. So they will have no issue in terms of that, I guess, because the expert are working with this company, be it the biological expertise, and also the computing, the IT, the AI expertise are all there. So I think, yeah, because this is a big company, so things like that are normally taken care of by
Yeah. Okay. Well, maybe if you have some connection there, I just want to.
You can explore, actually. Just Google. You can explore, because I'm sure they like to replicate the system in other parts of the world. That's really a possibility, because this kind of system, they may be under pattern or something like that. So there's always a possibility to explore of buying the pattern, or using the technology or something like that.
Something like French fries.
Yeah.
Franchise.
Yes.
Franchise.
Yeah.
Not French fries, sorry. Franchise.
Smart floating system.
Yeah, it's because it's a very good idea, especially Singapore has a small small country, and they are expanding very fast.
Yeah.
And the second one, I'm sorry, regarding your subject, this is a new subject, right, in your faculty?
Yeah, I'm not teaching the subject, actually.
I'm sorry.
Yeah, we do have publication on several topics which I co-authored with other professors. We are not having the background in this one, so it's merely based on interest and readings and things like that. So I would say my knowledge is not so deep, it's more superficial. I can't really explain to you beyond the 3 layers and just now if you ask me something very deep, I have to surrender. But I never take this kind of subject during our have formal
Aulia.
Okay. Maybe the next time we have I will have sent email to you. Thank you very much, Ms. Rosita.
Okay, thank you, Aulia, for your questions. And another one, I will read it for you, Prof. Rosita. This is from Amelia Nambada from Brawijaya University. It was explained earlier that this system uses sophisticated technology. Well, is there no negative impact from using this system? Thank you, Prof. Rosita. What is the negative impact of this high-tech technology system?
I think just now, like I said, of course, one of the question by Prof. Apa tadi itu? We may be, we may be replaced by robot one day when it comes to labor. So another,
I mean, Prof. Rosita, probably this negative impact means like not really the advantage
community.
No. I think it's from the system itself. When we have high technology, what could be the negative impact of the system?
I don't know, honestly, that I didn't come out anything mentioning about the downside except for 2 things. One is cost, very expensive, meaning if it's very expensive, if you don't produce enough fish, you cannot sell enough number of fish, then it will be a loss, right? So that is
that's right.
one. Yeah, very expensive. It can consider expensive at the moment. And of course, any system, any aquaculture system, whether it is AI or not AI, it is still having a risk of malfunction or anything like that. Because this system is cultured in high density, because they have, I saw this aeration tube with the oxygen, they use very pure kind of oxygen for aeration connected. And then if things happen, because, even though it is controlled by computer, things still can go wrong, right? So you can lose, a quite number because you're using high density. Once you lose one tank, imagine you will lose your stock, your fish stock. So this is the only thing that I can remember. When it comes to like the environmental impact, I think they are very, very advanced in terms of that compared to the traditional farming technology, whereby, we always end up, the waste going to the river, going to the environment, the natural environment, rather than being treated. In this case, in smart farming, the waste should be taken care of already because of the nature of the system, whereby they make sure the waste will not be released to the environment before they are being treated. And RAS is also normally used. So that is the only negative impact that I can think about at the moment.
It seems like so perfect, this system already.
But
because
there's
no
not
waste.
so many in the world yet. So it is interesting to say what happened to this Singapore company in maybe 3-4 years time from now. We would like to know the progress, right?
That's right.
So, I think
but then
will be very interested to know.
But then we have to also consider about the more traditional system that probably the villagers had or something like that. So if it is dominated by this high-tech aquaculture system, production And then probably Singapore, or I don't know, maybe there's no like fishermen or villagers in Singapore that have traditional aquaculture system like in Indonesia, probably, Prof. Rosita.
I think they do, depends on places maybe, right?
Yeah.
I saw another question here from Komang Ayu.
Yeah.
She said, sorry, is a he
Yeah.
or she?
It's a she. She.
Okay. What do you think about the advantage and disadvantage using this very high tech? Oh, I think we have discussed this, right? Advantage, but in the country like Indonesia, maybe she want me to, comment if Indonesia want to embark on something like this. I think Indonesia is blessed with natural resources. Very, very blessed with natural resources. You have still a lot of, fish stock from your wild. I visited a few farms in Tarakan,
Yeah,
Indonesia.
in Kalimantan,
yeah, Kalimantan. They have this tiger prawn from the wild as their broodstock for their hatchery, which is very successful. In our places, to get broodstock, tiger prawn broodstock is quite difficult these days. But in Tarakan, I see that they can get it very, very, easily. The only thing is they have to cut so many mangrove area, which I think is not sustainable. But yeah, that is an issue, I think. So if Indonesia, I think, would like to go to using this system, is also, I think is a very, very good opportunity, even though you have huge land that is still not developed for aquaculture, for example. You still have,
that's right.
You
That's
have
also one.
a huge coastal area to be developed for cage culture, for example. But still, if you can, incorporate this technology, why not? Even though I don't see anything wrong. Indonesia is a very, very, what do you call, rich country. You are blessed with natural resources, everything. So it should be managed sustainably. That's my opinion. By having technology, by having technology, I think we can manage it in a better way.
Thank you, Prof. Rosita. I guess, you're right. We still have so many places that not yet developed and so on. Yeah, probably if we have like this system, the government have to make sure that the production will be, like cheap enough to be obtained by the middle class or even lower class. Yes. All right. I think that was the last question for this question and answer. Then you may continue your lecture, Professor Rosita, and we will break another hour probably, or probably another hour first and then half hour later.
Okay. Hang on, yeah. Okay, we will continue again. Just now, Pak Eko yang asked me about what should be understand first before we start the processing. He is interested in processing, right? So, like I said, you have to understand your fish. Yeah. So now the lecture is about understanding your subject. In this case, we propose tilapia as a model. How do we develop this smart farming concept, or how do we integrate this AI, whatever technology that we have discussed just now? So we are proposing, like, in other research, sometimes we use zebrafish as model for understanding certain physiological process or something. But for this one, we propose tilapia as a model. So tilapia is one of the most established aquaculture species, right? There are so many studies have been done on tilapia on different aspects, on different what do you call subfield of aquaculture, nutrition, health, you name it. So as we know, tilapia is one of the top 10 farm species in the world, and we expect it will grow further in the future, and expected by 2030 to yield 7.3 million tons. So being one of the most thoroughly investigated finfish in the world, the data generated on its performance in culture system offers a great deal of insight needed for A1 application. So in a way that this is the same like what Pak Eko was asking me. Before we can create the what do you call the system, we must have this parameter first. What do we want to analyze? You remember the 3 layer, the input, the middle layer, and then the output. So we must have the input first. This input, we propose a model which is tilapia, because a lot of study already available. So we can use this available data as our parameter, the input parameter that we're going to use in the middle layer, which is the whereby the machine, the computer, the AI, everything will analyze, the synthesis will happen there. Okay, some basic attributes of tilapia specifically suitable for AI application in areas such as stress detection, including a strong receptor effector system, well-defined behavioral changes in response to environmental factors, sensory system having a remarkable ability of perceiving external stimuli and provoking reaction in a way that helps the fish adjust to prevailing conditions. Okay, let's say the industry or company want to develop, for example, stress monitoring system, or whatever system that you want to name it lah, to monitor health status. For example, there's a system to monitor fish health, for example. But for me to monitor fish health, I need this raw data. In this tilapia case, because we have many research available, and then we can have these tilapia, they have a strong receptor effector system, meaning they can they're having system that is able to translate their effect when some form of stress, be it temperature tinggi, ada penyakit, something begitu, what is the response, and then well-defined behavioral changes, yeah, whether they swim very fast or hiding at the bottom, something like that. And then this will be able to be used as the raw data that will be analyzed by the computer. We can do the programs, you know, and then this one will be used to translate what should be done, or the result we put, or fish is under stress as a result of the system that we develop, or fish is hungry, something like that. Okay, let's have a look at the response of tilapia to stress factor. Let's say temperature. The response of tilapia: decrease in operculum movement with temperature decline. You know operculum, right? In our biology, physiology class, the first time. So with this parameter, we can set the computer to understand when fish, in this case tilapia, exposed to certain temperature, their response is in terms of operculum movement with temperature decline. So later on, the sensor, if operculum move, it will translate it into, oh, this is due to temperature. You can translate, but We are the one who provide the parameter actually. This is how they are using programming. Like if, like this. I think some of you may be familiar with the word, the programming wordings, right? If, how they write program. And then reduce random movement, declining in swimming activity. DO, increase surfacing, crowding, sluggish response to stimuli. So these are the parameters that being used to classify DO, this one. Okay, salinity, increase opercular rate, also increase vertical movement, disorientation, exhaustion, more time at the bottom. Unionized ammonia, initial shock, increase agitation, followed by decline, increase vertical movement. So they will develop some sort of mathematics, sometime maybe physics, on how to measure what is the movement, the width of movement, the length of the movement, things like that. We are not going to learn how to develop the, the system here, but we just want to understand the concept. Okay, so I hope you are okay with that one. Now we move to what we call future food choices. When it comes to IR 4.0, future food is also another topic that is relevant with the technology, because the presence of technology allow us to create more innovative food product. There is nothing very technical about this popular term future food. Some authors define it as food that we'll be eating in 20 years time, meaning now 2021, 2041. But it's better to refrain from fixing any year and decade as it seems arbitrary, which is true. So this is just, we defining casually, like maybe in 20 years time, that is what we mean by future food. Food security is a challenge for the world and is likely to get bigger in near future. What we will be eating in the future is a matter that is receiving a great deal of attention. Okay, when it comes to seafood, we expect to consume more or less what we are consuming right now. In 20 years time, we still consume fish, shrimp, squid, same seafood produced but in different ways. You see, might different approach already. Same seafood raised by different culture system. For example, organic farming. New species like what we discussed as functional food. You know the term functional food, right? It is consumed for the purpose so that it will give you benefit in terms of health, for example. So there might be some species like seaweed will be used as functional food, no longer as your source of protein, or of course, seaweed doesn't have much protein. I mean, they are serving as something else, something is more valuable, is functional food, yeah? Let's say we consume certain part of fish body for the purpose of functional food, like a supplement, things like that. Of course, 3D printed seafood. Yeah, this is, I'll share with you what is 3D printed seafood. Oh, okay, this one. So this future food is also another venue that us as aquaculture people may want to explore.
Grammarly can help you write quickly and confidently, so you never have to slow down at work. Stay on top of email.
Did you know that only 20% of the fish that we harvest globally each year actually ends up in our stomachs? That is a lot of wasted valuable food. So countries throughout the world, they are taking action to get the most out of the fish we harvest. We are here in a modern fish processing plant in Iceland, where 4,000 tons of cod and haddock are processed each year. Producing a fillet of fish for us to eat leads to a lot of byproducts that often are wasted or find low value uses. Examples of byproducts include cutoffs and trimmings after filleting a fish, or good fish meat still left on the bones after processing. We can make high quality, tasty products from these raw materials using proper processing technologies and techniques. One way to do this is to recover the fish meat from the byproducts. This meat has the same quality and nutrition as the meat in a fillet, and now we can get so much more from each fish we harvest. With further processing, we can recover this fish meat and can make tasty farm seafood products like fish balls and surimi crab sticks, which you will find in your sushi rolls. But we can go even further. This is the future kitchen, where seafood sustainability meets cutting-edge technology. We are inside the Foodini, a 3D food printer, a device which allows you to customize the shape, size, and composition of your food, layer upon layer. Future kitchen tech devices, like the 3D food printer, can help us better utilize our seafood and reduce food waste. Researchers and chefs, they are now looking into ways to take these underutilized seafood materials and create novel seafood meals using 3D food printing. This is an example of an innovative technology that can bring us more fish to our plates and get us more connected to our seafood.
Interesting, right?
Very interesting.
Yeah. Do you have 3D printer in your faculty? We don't. We want to buy, but it's quite expensive, so we don't. We really wanted to have one, but until now we we cannot get it.
What do you mean by 3D printers?
Just now, like what you see.
Oh, I see. Oh, that was.
Yeah, it's a printer, but it can print a 3D object, which is in this case the food, 3D food, like the one that fish shape food.
Oh my God.
Yeah. So very interesting, actually.
Yes, very interesting, Prof.
Okay, I continue with this slide. Trends in future seafood. I think it's also interesting to know what are the trends in the future seafood. So the species in the current production system is the first column. If you see fish, shrimp, or crab, yeah, and then species in the future production system, maybe at that time, 20 years later, we will have organic fish, but still we have shrimp, also crab produced through certified organic aquaculture methods. Things like that is more to awareness about the food safety and environmental issue kind of things. Yeah. So advantage for future farming, of course, better health when we eat fish that is certified organic, for example, that is free from any antibiotics, because at the moment we are not really sure if we are eating shrimp that really free from antibiotics. Okay, second example is lobster from the wild, because at the moment I don't know any country in the world that is successfully producing lobster from larvae to the market size at commercial level. Of course, I know University of Tasmania, Australia have patented this lobster technology, but then they are not yet produced in mass production. So hatchery produce and farm lobster. At the moment, we don't have this, but future, we might be successful. We don't know who is going to be the first to produce hatchery, produce lobster, farm lobster. All this while we are eating lobster from the wild. But in the future, we anticipate maybe we are able already, because there are already a technology in the patented by University of Tasmania, and they are ready to sell. Actually, one of the Malaysian company has agreed to bought it. I think they bought it already, but then it hasn't translated into commercial scale yet. So there probably opportunity in the future that we will be able to produce the fully aquaculture produced lobster. So advantage, of course, increase in supply, decrease in overfishing pressure. Of course, this is quite true, because lobster is high value, very high market price, very nice, people in high demand. So in the wild, our lobster is really under fishing pressure. Okay, fish farm as primary food. This is now. In the future, 20 years time, maybe fish, I don't know, hopefully this is not true, fish become our functional food, like your vitamin. Because of the limited quantity, we can't eat fish anymore. Very sad that we can only have it like in a fish oil capsule, your vitamin. I hope this will not realize. I don't really like this one actually, but this is might happen also. Yeah. So advantage is specific health benefits. Yeah. Microalgae harvested from the sea. This is what we are doing now. But in the future, we believe that we can produce the large commercial scale under control. Of course, I know there are several countries, maybe Indonesia also, you are producing a microalgae at commercial scale, but in the future, the condition might be optimized and better, I think. So exploring the potential of new species could open many horizons for their use as functional or regular foods for humans. Last, mushroom or fungi, known or new species raised through agri-aquaculture system, mush aquaculture. We know that commercial mushroom is grown in this kind of set up the plant, the mushroom plant, but we might be able to grow mushroom in our integrated with our aquaculture system, just like this, what you call aquaponics with other plants, the vegetables. So this is this might happen also. So mushroom are the source of nutraceuticals and therapeutical substance and bioactive compounds of functional significance. Okay, we continue again on the application of AI and other tools of current technologies to future aquatic food is practically more plausible due to a number of reasons. First is opportunity to select species that can be grown on a fast track. Second, determining amenability of new species to technology-intensive farming system. Third, shaping the production system consistent with the sustainability requirement. And last, using species according to their ability to accept nutrient fortification and bioencapsulation, qualities that make them acceptable as functional food, and biological capacity for accepting integration into system of macro cascading for eco-friendly spin-off benefits or socioeconomic dividends. And lastly, suitability for organic aquaculture. This is another factor that might help the application of AI in future foods. Okay, another emerging area is imitation seafood. Actually, I think we already have it now, right? Like the one we see in the video just now, the false crab meat that we normally have in our supermarket. Several plant-based recipes for imitation fish are being developed. For example, raw tuna and salmon. 3D printed imitation seafood are opening a vast horizon of new opportunities. This is an area with enormous potential for secret recipe, innovation, entrepreneurship, graduate employment, and startup. Meaning to say, if you ever go to vegetarian restaurant, they have imitation of beef, right? From soybean base. I went to I think a few times to vegetarian restaurant, but I never feel full eating vegetarian food. They use, you can order beef. It looks more or less like beef. It tastes more or less like beef, but they are not beef. They are soybean based mostly. So we are expecting the emerging area are also not only to replace that the one in the vegetarian restaurant, but also they are imitating the seafood also by using different kind of ingredient, of course. So this is another area that might happen in the future, more and more imitation of seafood. I'm not saying this is good, but I'm just sharing the possibility, okay? Promising sources of ingredient for imitation seafood are seaweed and mushroom. Mushroom is very dynamic, you know. It tastes sometimes like meat, you know, very meaty also. So it's easy to manipulate mushroom into something else. Indonesia, I believe, and also Malaysia has a vast coastal marine area for seaweed farming. You are quite advanced in terms of seaweed farming. We need to learn a lot from Indonesia. You know Kapafaikas, right? We only have one place in Sabah or in Malaysia that is so-called suitable for Kapafaikas farming. The water, it is in Semporna. It is a very pristine water quality, very nice coastal area, whereby we successfully culturing or farming Kapafaikas, the seaweed. But when I visited Tarakan, they have a very muddy sea water. But then you are producing a lot of seaweed, but of course, different color because of the mud, the influence of the water, but still the production is very high. So what I'm trying to say is, sometimes we have to go beyond science. What we know that, you know, these species can only be grown under this condition, blah blah blah, in this turbidity, temperature. But it has to be, I think, you need to prove it. Then only we believe that it cannot be cultured here. Otherwise, it is a waste not to experience it. That, you know, you can manipulate certain condition, for example. So seaweed is another emerging area that we can consider. Mushroom are easy to farm under certain agriculture system due to their survival and growing condition in tropical climate. Sorry, the T is they do not carry out photosynthesis, and thus there's no need for vast sun exposed area. Fibrous nature of mushroom offers the advantage to turn them into product that is somewhere resemble from animal sources. Like I said, mushroom is very meaty, you know, that tastes like meat. Furthermore, mushroom do not have a strong taste of flavor. This help in our imitation, like adding artificial flavor into it. So use of mushroom in such future food will intensify interest in exploring the most suitable edible species out of 1,000 that are known to occur. I think this one I have shared with you. Hang on, yeah, I don't know why is it not. I almost come to my
It's okay, Professor Rosita. I think the rest,
Solution. Okay.
when you finish, yeah.
I still have two
Okay.
slides. Okay, I
All
finished.
right.
Okay, we also discuss what are the solution available, yeah, especially in terms of quality control to curb malpractices in the imitation of seafood business. We don't want also, you know, they are offering product that is not safe. So once the consumer interest picks up, the market is likely to expand and the public will be better informed. The nature of ingredient, quality assurance, price awareness campaign, and consumer appeal will determine their success. And then, of course, certification these days is important. People will be more confident if they see some certificate appeared in your food product. Traceability, of course, blockchain. Okay, maybe later I'll discuss about blockchain, will be needed to ensure that only quality product enters the market and consumers get what is claimed by the producers of the food item on the label. Blockchain has the capability to trace the entire life cycle of food products from origins to consumers. It can help combat fraud in the food market, boost transparency in operation involved in processing. It will be possible to track and trace any seafood in the market and might emerge as the solution to critically important food safety. Again, the solution will be with IR 4.0 technology, which is the blockchain technology. Basically, blockchain technology is just like account ledger, you know, accountings, they have ledger, right, to record what are the things. So the same thing with blockchain that we have now, yeah, is a kind of ledger, a centralized bookkeeping, but this is online. You know, someone do transaction and goes to this, what do you call, network, the computers, and then you need to do validation, which is protected, you know, and then verified, and only a new block is added then to existing blockchain, and then completed your transaction. It's difficult for me to give example, like cryptocurrency, you know, cryptocurrency, Bitcoin. Are you playing Bitcoin here, anyone? I don't play Bitcoin, but this is online currency. We don't see our money, ringgit or rupiah, can't see. This is all cryptocurrency in terms of
cyber coin, no, there's
like
no existing coin.
True, it's Bitcoin they call it. So this technology can be used to monitor, because there is some sort of security available, you know, traceability, you know, which transaction come from which country, what time, when, how much, everything need to be validated and then verified using this complicated system, you know, so that then only the process will complete. So something like that. This will help the whole IR 4.0 technology will be implemented in a safe manner in terms of safety. But of course, there's always hackers here and there that will, you know, might put some virus into the system or something. That one is always happening all the time. But just want to share you that this blockchain technology can be used also in our transaction. Yeah. Okay, hang on. Last slide is, let's watch the video before I stop my lecture for today. Okay.
Biosort presents iFarm, Individualized Aquaculture. Advancing from group-based farming to an individualized approach is revolutionary in salmon farming. iFarm consists of a custom cage top, a V-shaped passage to the surface, and an iFarm sensor. Salmon naturally swim through the iFarm sensor as they rise to the surface in order to fill their swim bladders. The salmon then return below the cage top to feed. The iFarm sensor scans each fish and uses automatic image processing to uniquely identify each individual. Precise weight and growth are measured for each fish. iFarm measures welfare indicators such as condition factor, injuries, and deformities. A number of symptoms are recognized, including loser fish, winter ulcer, discoloration, and other external symptoms. Sea lice are counted on the entire fish. The operator can tell the system to sort individual fish to customized treatment. Sorting and treatment of only the selected salmon is a revolution compared to current group-based treatment. The fish can be moved gently for the treatment of individual fish, a group of fish, or the entire site. The result is less stress, injury, and disease, and a better appetite. An interactive feeding model improves the feed conversion ratio. iFarm can sort fish by weight and size. Fish above 5 kilograms can be sorted to a separate cage for processing. A warning system detects if fish are missing and makes immediate action possible. Fish with lice can be sorted out. And treatment is only applied to fish that do have lice. The custom top also keeps the fish at a depth with very few lice. iFarm generates reports for all desired data. iFarm advances cage-based farming to a new level, improves fish health and welfare, and strengthens Norway's advantage as salmon producer.
Okay, I think very interesting video. That's why I share with you, and very advanced. Right? They have a system that able to detect the parasite, how many, what kind of, and then they can separate those infected, then those healthy one, and then infected one will go a different tube and go for the treatment. The only thing that I cannot understand is how are they treating the infected fish if it's chemical based, and it's very difficult in the water you want to treat with. But there may be some other form of treatment that I don't know, maybe use radiation or UV or something. But this concept is truly what do you call AI?
Yes.
Yeah.
Really futuristic.
True. But it's available outside there if you're interested to buy the technology. So
Wow.
that is the end of my slide for today. So maybe we open for question again.
Yeah. Thank you, Prof. Rosita.
Or if you have anything that you want to share, yeah, please feel free. I would like to, I would love to hear also from maybe the lecturers, your own experience in, not necessarily in commercial setup, maybe in your experiment, something that, yeah, I would like to learn also from you all, because I know you all are very experienced researcher in your own field. So this will be a very good platform for us to share our experience, or even with the students. Not necessarily you have to ask question. If you want to share anything interesting, any new information, so I'm very open to that.
All right, Prof. Rosita. Yeah, for this moment, probably I will just open a question first. Later, if some students or our colleague are ready to share something or even discuss something with you, then we will welcome them. Okay, dear all the students, dear colleague, if you have anything to ask or to discuss with Prof. Rosita, you are welcome now. Okay, there's already some, oh no, it's already, I read it. Any questions? You want to, I saw previously, I think someone already raised hands, but doubt it. Oh, okay. So we still wait for the questions. And yeah, probably I will just only ask a question as well, Prof. Rosita. Yeah. Yeah. For instance, like you mentioned in one of your slides that about the what is that, the GMOs fish.
Oh, GMOs. Okay.
Yeah, GMO species. Why do you concern about its ecosystem? What is that ecosystem factor? Do you mention it in one of your slides, Aika?
Okay. Yeah. I understand your point. You may want to ask me the question. Maybe you think, why do we afraid of GMO going to disturb the ecosystem, right?
Yeah, that's right. That's right. What is your concern?
If you are talking about fish, you know, GMO, genetically modified organism, is normally superior performance than the
local
original, than the original fish, because they already taken into consideration the best gene, the best trait that fish have, then produce a very good species, meaning very superior than the original species. If they are exposed to the environment, natural environment, for example, to the river or to the sea, we are afraid that they become, you know, dominant, you know, in terms of food, you know, they become more, you know, they are the one who's going to have more
survive.
Due to their ability, they have a better size, for example, than the original one. So things like that we are afraid that it's going to disturb the what we call is the ecological balance in our nature. So things like this, but still, like I shared just now, actually GMO species has also what do you call significantly increase our production also.
Okay, yeah. Oh, in that matter that your concern is about in ecological aspect. But don't you think, for instance, like I'm not really researchers in what do you call it, catfish. Do you know catfish?
Yeah.
I think in Indonesia it is really a bit difficult now to trace back the original species of this catfish in the wild.
True.
Because all all of the, even what we call like what's that, original or local catfish, lele dumbo, do you know lele dumbo, the bigger size of catfish? That one was already I think hybridized this species.
Most catfish that we have now is hybrid. I'm not sure if they are GMO, because GMO is slightly different from the hybrid. Hybrid is just crossing to different species sometimes. But if GMO, we modify the genetic material. of the fish. Yeah, yeah. Normally that is what we are trying to, because some fish, some people, you know, have a bad review with our hybrid grouper. They said
Oh, I
this
see.
GMO or something, because hybrid grouper is not really a GMO, because we don't do anything to modify the chromosome or anything about the genetic materials. What we did is simply crossing two different species, that's all. And unlike the other species maybe that really went through genetic modification. So I know that not even in Indonesia, I think most of the ASEAN country like Thailand,
Yeah.
catfish is hybrid one. What we are using is the hybrid catfish. What we are
Oh, okay.
capturing. Yeah.
So, yeah. Oh, now I know that the hybrid is not really exactly the same with GMOs
Yeah,
species.
yeah. Sebab we don't really modify the genetic, but like if we modify, let's say the triploid, you know, triploid fish,
Yes, yeah.
that we give shock to the fish. I still remember during my first year, during my first degree, I do some catfish study on triploid. I shock the fish with ice, cold shock.
Okay, yes.
So with the cold shock, we alter the something to do with the chromosome, something like that, so that the fish will have bigger size later on, something like that. So that one I think is considered changing the genetic maybe. So
Yeah.
GMO is quite controversial. People have sometimes different definition to this GMO. So
Yeah.
it is very controversial what do you call issue.
Okay. Yeah. Well, yeah. Sort of like we create a new species or something like that.
Yeah.
Isn't it? But then I was thinking still, if you're successful creating a new genetic code in this kind of fish, and then you try to hybrid again, hybrid again with with more local one, don't you think that they produce probably a better offspring?
Yeah, by right, the idea of hybrid is to produce a better offspring than the parental species. But not all hybrid produce this good trait. We have tried like 7 kind of hybrid, different species of grouper, only 2 that is producing positive outcome. The
Oh,
rest, they
okay.
are not surviving, low survival, things like that. So it's not really working on some species. So yeah, it's hard to say sometimes. But I
Wow.
know in other fish there are hybrid also. In Japan also many hybrid fish they produce.
Yeah. Yes. I guess you must have a lot of experience in your lab, in your research center, Prof. Rosita. That will be very interesting to see which species is succeed and which one is not applicable for this kind of technology or yeah,
Yeah,
way of.
I just produced one book last year during my sabbatical leave. I took sabbatical leave for 9 months. I don't know if lecturer in Brawijaya also entitled for, do you have sabbatical leave? Cuti
No,
sabbatical? Enggak.
no, we
Oh,
don't have.
I see in
Usually leave only for maternal. Yeah, no?
because in our university, all Malaysian university, they have what we call sabbatical leave. Sabbatical leave is actually meaning you want to be away from the university. You don't want to do teaching, everything. You just want to unwind yourself and doing something else. So
Really?
yes.
But you still paid. I mean,
Of course. It's our entitlement to have this leave. So
Wow.
when during my 5th year as the director for Borneo Marine Research Institute, I suddenly feel very tired. I said I think I have contributed as a director for quite some time. So I asked the Vice Chancellor, is it okay if I get my sabbatical leave? And then I said, yeah,
Wow.
you can go. So I got 9 months leave, and that time
Wow.
I used it to write a book. I write a book on hybrid grouper. It's available in Shopee.
Okay.
Yeah, if I have chance to go to Brawijaya physically one day, I'll bring the book for you all.
Wow, that's good.
Yeah, in
That's
that
good. Wow.
book, I share different kind of hybrid available. I think I still have it here in my laptop in the photos. So yeah, very, very interesting combination of hybrid grouper that we
Yes.
produce.
Yeah, because you mentioned GMOs, so I was thinking like the same as hybridization or something like that, but actually it's not really the same.
Because
but still very interesting.
Hybridization has 2 types in general. One is interspecific. The other 2 is intraspecific. This intraspecific normally regarded as a GMO because the genetic material is modified. Intraspecific, like the one in tilapia, they use tilapia, and then they cross, they change the genetic material so it become what they call GMO. But there is no proof also that, you know, when we eat GMO fish that, you know, it will put some negative effect on your body. Same thing with soybean. Most of the soybean is actually GMO.
Yeah.
Yeah, but I don't know, many things that we still don't know, but in general people trying to avoid it, right? But I don't know.
Okay, Prof. There was one or questions in the chat from Maudi Ferrari Ardianti Putri. Wow, a long name. She wanted to ask, in the video it is explained that the fish will be sorted by size and behavior. My question is, the tool is used to use the use wave system, can the fish body or brain catch all the waves, or only few fish can catch the wave and then the fish can enter into the technology? Oh, okay. do you understand the questions, Prof?
Tidak begitu paham apa maksudnya, can
maybe the last video, Prof, the very last video.
Dia kata, can fish body or brain, adakah badan ikan atau otaknya boleh catch all the waves? Apa maksud di sini catch the waves ya? Mungkin
probably
mau terangkan, Maudi?
the fish, probably the was that the fish enter the chamber. When entering the chamber.
Mungkin Maudi bisa jelaskan dalam bahasa Indonesia.
Ya, Maudi silakan.
Oke, maksud saya saat di situ kan ada teknologi. Nah, teknologi tersebut untuk ikan masuk ke dalam teknologi tersebut apabila menggunakan sistem gelombang, biasanya teknologi tersebut itu menggunakan teknologi gelombang yang membuat ikan itu ingin masuk kepada teknologi tersebut. Nah, pertanyaan saya, apakah setiap ikan ini memiliki daya gelombang yang sama, tarik ikatnya, daya gelombangnya itu sama atau tidak, atau hanya beberapa ikan yang memiliki otaknya itu untuk menangkap daya gelombang itu bisa gitu, atau semua ikan memiliki daya gelombang tersebut gitu.
Kamu mengatakan daya gelombang, malah Ibu bingung menerjemahkan. Itu singkatnya barangkali Prof Rosita, itu bagaimana ikan masuk ke dalam chambernya tadi itu?
Itu kan tadi dia memang macam seakan ada dia punya tunnel kan, ada
ya, ada tunnelnya itu.
And then bila Bila sensor, dia gunakan sensor. Saya lihat dia guna sensor. Bila dia detect yang ikan yang ada warna oranye, ada penyakit maybe, ada sea lice. Sebab komputer itu sudah ditrain untuk detect sea lice. Sea lice itu kutu parasite di badannya salmon. Jadi bila dia sensor itu detect itu, ikan itu consider sakit. Jadi ada satu tadi itu seakan apa namanya itu yang one device tadi itu kasih pisahkan apa? Mari kita lihat lagi nih. Pisahkan badan apa ikan yang sakit itu ke tunnel yang lain, lorong yang lain.
Biosort presents iFarm, Individualized Aquaculture. Advancing from group-based farming to an individualized approach is revolutionary in salmon farming. iFarm consists of a custom cage top, a V-shaped passage to the surface, and an iFarm sensor. Salmon naturally swim through the iFarm sensor as they rise to the surface in order to fill their swim bladders. The salmon then return below the cage top to feed. The iFarm sensor scans each fish and uses automatic image processing to uniquely identify each individual. Precise weight and growth are measured for each fish. iFarm measures welfare indicators such as condition factor, injuries, and deformities. A number of symptoms are recognized, including loser fish, winter ulcer, discoloration, and other external symptoms. Sea lice are counted on the entire fish. The operator can tell the system to sort individual fish to customized treatment. Sorting and treatment of only the selected salmon is a revolution compared to current group-based treatment. The fish can be moved gently for the treatment of individual fish, a group of fish, or the entire site. The result is less stress, injury, and disease, and a better.
Profesor, mungkin pertanyaannya adalah bagaimana ikan itu tadi naik ya, naik ke arah chamber.
Iya, iya, lebih kayak gitu, Prof.
Jadi apa yang faktor apa gitu? Ya.
Saya paham sudah soalannya apa nih tadi. Saya lihat masa ikan itu masuk di tunnel, ada kan satu apa itu macam rakers yang masukkan dia ke dalam. Maksudnya mungkin soalannya kenapa saja ikan itu mau berenang satu laluan dia tidak kembali ke belakang atau something begitu, kenapa dia ikut sahaja itu laluan lah kan? Is that what you soalannya?
Tidak, Prof begini. Jadi dari ikan yang ada di tank tadi itu, di tank itu dia bisa mengarah ke chamber tadi itu karena apa? Karena faktor apa, Prof?
Mungkin arusnya sudah dibuat gitu kali. I'm not 100%, but the way I understand it, dia seakan-akan dia punya current is following ikut tunnel itulah. Cumanya yang saya belum bisa bayangkan sama ada tunnel ini adalah netting atau is it enclosed? I really cannot visualize. Belum lagi saya begitu boleh memahami yang kalau in reality-nya bagaimana begitu. But I suspect dia punya current air itu memang mengarah ke situlah. Mungkin dia ada buat the system so that ikan itu secara otomatiknya akan ikut air yang mengalir ke bahagian yang sudah diapakan lah. Mungkin dia ada pump system or something. Ya. Maybe.
Oke, jadi mungkin Maudi itu memang seperti ikannya diarahkan ke sana gitu, ke tunnel itu gitu. Jadi bukan bergerak sendiri, tapi arusnya itu mengarah ke situ. Seperti kalau kamu lihat di farmnya ternak itu digiring masuk ke satu apa ya lorong gitu loh.
Ya.
Ya.
Betul.
Jadi ikannya itu bukan bergerak sendiri, tapi memang sudah diarahkan masuk ke sana gitu.
Ya,
Lalu
sepertinya
oleh
dihalau kan, dihalau ikut laluan itu. Jadi semuanya
ya,
macam juga kambing yang pulang ke kandang kan, dia sudah mungkin ikut kena
betul.
laluan. So interesting konsep dalam smart aquaculture. I don't know when it can be realized in our country because
That's true.
one, yeah, offshore. Maybe tomorrow, tomorrow I will share with you the offshore aquaculture concept under sustainable aquaculture topic. So there will be more interesting video tomorrow also, so that easy for us to visualize rather than if it's all in writing. I also becoming sleepy reading my slides. So yeah, I think the video it's helping a lot. Yeah, this day.
Yes.
Yeah.
That's right. I think you once in a while you play video. I think it helps.
Yeah.
It helps. Yeah. Okay. Is there any other questions? Yeah. I saw. I think Gomez. Gomez, you raised your hands previously. Okay. No, there is still no questions again. Yeah. Actually, we wait probably another 5 minutes, 10 minutes. If there is no question, we can. Oh yeah. Okay, there's still no answer. No question in chat. Okay, dear audience, students, do you want to ask question to Prof. Rosita? Not yet, Prof. Not yet. Yeah. Okay. When there's still no questions, okay, Prof. We will discuss based on your previous topic. I think the fourth industrial revolution technology. Okay. Oh, you show us your book.
Yeah.
You are really not in a leave, I suppose. You are supposed to be on holidays. But you try to find your own time for writing.
Okay, this is the hybrid that we have done in our hatchery. You see, starting 2006, this is the most successful hybrid, yeah, between Ephenephilus fuscogutatus and Ephenephilus lanceolatus. This is the hybrid grouper that is cultured in Southeast Asia already now. This second one is also successful, but less impact, I would say, Coides and lanceolatus. The rest, not that. They hatch, but very low survival and then end up very high mortality. So many species we try. Ini kan kerapu tikus juga jadi, tapi tinggal like up to how many ekor saja lagi. So memang maksudnya Chromileptis dengan Ephenephilus is quite distant family. It's not like this one is Ephenephilus with Ephenephilus, but it's surprising. Ephenephilus dengan Chromileptis juga bisa di what do you call di hybrid, tapi tidak begitu sukses. Jadi ada banyak yang ini yang hybrid yang paling bagus itu antara tiger, kerapu harimau, kerapu macan ya di Indonesia.
Yes, that's what I want to say. Macan.
Ya, ini yang orange tadi itu orange spotted dengan macan. Yang ini adalah kerapu bebek kan, Chromileptis. Bebek dengan macan. Dia jadi begini. Ya. So, antara yang apalah yang sudah kami hasilkan in our
So do you hybrid them naturally, or you
No, induced
inject?
spawning, inject.
Oh, okay, injection, using injection, yeah. So what is how is the performance of these three?
Yang hybrid tadi yang pertama tuh yang macan dengan yang giant grouper itu yang paling bagus lah, yang paling very good performance in terms of growth pun cepat dan tidak fussy makanan, boleh dia accepted almost all type of formulated feed, and then quite resistant. Also we do some challenge tests. It turned out that they are quite hardy, but still of course they are also exposed to certain diseases like parasite and all that. So very interesting species, and I think it is a good candidate for culturing in our changing climate, our changing environment, with the ocean acidification and all that. So hybrid grouper is quite hardy in terms of performance.
Oh, okay. I think really interesting of what you have found in the hybridization of this grouper.
Yeah.
Because the grouper is still considered very expensive fish though in Indonesia.
Yeah, definitely.
Yeah, so that's why all research in this species will be worth it. Okay, there's still no questions, no raised hands. It means that your lecture is very easy for them to understand.
I hope.
Because there's no questions at all. So it means that they really understand of what you have explained. Yeah, probably just a light discussion while we are waiting for them to ask, probably. Professor, when I recall back all these, was that fourth industrial revolutionary technology applied in the aquaculture system, the product must be very expensive, right? Or wrong?
Sorry, come again, Bumi?
The fish produced from this very high-tech aquaculture system,
True.
it must be very expensive, isn't it? Or is as cheap as produced in more traditional way?
I don't know, but let's say if this, for example, the Singapore farm, if they are able to produce how many just now 270 tons per year, something. So if they're able to produce a very large number in a short time, meaning low cost in everything, so they will be able to sell in a reasonable price. Yeah. Provided they are success in producing that number, because they are talking about high density, very efficient system, less water, unlike the conventional system. So maybe they can reduce the cost in the production. So it's not necessary they are going to be very expensive, but the only thing is if they claim that their product is something like organic, green technology, that the label makes them expensive. That I think will happen. But in terms of overall costing, maybe if they produce it efficiently, even though the starting cost very expensive, they produce a lot of fish in let's say have many cycle per year. I think they can sell in reasonable price.
Yeah, that's what I think about. Like their production might be very high, but then their technology is also cost very high as well.
Yeah.
So
but
probably
if you see the cost just now is only 3 million USD. It's not that high actually. 3 million USD, 3 million Sing dollar, 3 million Sing dollar. Because like I said, our hatchery now is also like 12 million ringgit. So almost the same. Yeah, our hatchery is for teaching. So yeah, I think it's quite reasonable for a company. I mean, for an industry punya company which is only 3 million US. Sorry, Sing
Yeah.
dollar.
So the government should be able to to purchase or to get this
Yeah,
kind of
because
system.
Singapore is depending on other countries to feed them. You name anything, all food types are imported, right? Because they don't have space, they don't have land. But recently I saw they are now also applying smart paddy farming. They are also cultivating paddy, sawah padi, tapi menggunakan konsep yang seperti inilah, smart technology, precision aquaculture. So they don't have choice. Singapore don't have choice because they don't have land. So that's why they are very keen to implement this kind of technology in their country. Because I think they don't want to depend 100% from import, yeah, to feed the country, because all this while I think all the fish, whatever like rice, everything they need to import. So if they have this their own products, maybe government will also set certain ceiling of the price of the fish produced from the system, so that the all sort of people, different walk of life, will be able to buy the product. If they sell at a very high price, maybe, you know, not all people are able to eat fish in Singapore.
Yes, I think for a country like Singapore, probably this kind of technology or high technology aquaculture system will be very, very suitable for the country, because they don't have land too much. The people, actually it's not really that high populated as well as Singapore compared to Indonesia. So yeah, and Indonesia will need a lot of production in fish for our seafood. Yeah, I was wondering probably if our government can provide provided with this high tech for several only, probably there will be enough seafood from for Indonesian people. Don't you think so, Rosita? Yeah, but yeah, there's always like you know, refusal or acceptance of this kind of technology, but then we have to move on, isn't it?
Yeah. Slowly, I think we need to adapt with that, because otherwise we will be left behind. And you know, technology normally associated with quality. So when it comes to quality, this is the part that we cannot compromise normally. So if we still using, you know, very old technology, for example, the quality, the safety of the product that produced might be, you know, of less standard. And so things like this is not good for a long run. So that I think we need to adapt with the new technology. Like when we first start fish farming, marine fish farming in our Southeast Asia, normally all farmers, all company using trash fish to feed their farm fish in the cage, right? Everyone using trash fish. But slowly, when they know the impact, the consequences, or even the cost, is not economic to use trash fish, so that they're willing to change to formulated feed. Now more and more farmers using formulated feed, because they already know the impact, what is the benefit, what is the disadvantage. So I guess same thing with this IR 4.0 technology. People will slowly adapt to it, and once there's demand and there will be supply, when the supply is is there, like let's say we want to buy phone. Last time phone is very expensive. There is demand for handphone. So many types of handphone available. So the price will be reduced by itself because of the supply is more than the demand, for example. Also later, all this technology will be able to be utilized by all types of people, not only certain, you know, who can afford it. I believe it will be, the price will be stabilized and yeah, can be afforded by all walk of lives.
Yeah, I think so. I think you're right, absolutely right. Now, you know, the more the technology become more available in a society, probably the price will be not that expensive, and so many people will able to get it, the society as well. Then might be everything will be change accordingly, I suppose. Yeah, it is very interesting to see this kind of technology actually. Yeah. Okay, Professor, since there's no other questions again, yeah, it is very interesting actually to continue discuss this topic. But then we can finish a bit earlier. Then it should be like about 20 minutes earlier. Yeah, but it's okay. Anything else that you want to add for today?
Not really, but if you still have question, then I will be happy to answer.
Yeah, I think I think all the students already understand. No questions. Yeah, but I suppose this kind of topic is really interesting to discuss. But then I'm become the only one who listen to you then.
you are number one fan.
Number one fan. That's right. Yeah. There's so many questions actually.
Future food.
I'll just call it an
if you want to see the future food, I can show you one video on future food on GMO.
Okay. Yeah, why not? We still have like 20 minutes.
Yeah, so see, I haven't really seen this one, but the title is GMO salmon in changing our food system. Yeah, so since you're interested in GMO, so let's have a look at GMO fish.
It's that Frankenfish is what we call it.
Frankenfish. That Frankenfish that they're talking about? Well, this is it. It's a bioengineered fish, and it's got a lot of people feeling a lot of things.
It is so unnatural.
It's the first bioengineered animal ever approved for consumption. And after 30 years of debate about whether we should eat it, it's now on its way to your dinner table. And it may forever change how we produce food.
We're here outside of AquaBounty's Indiana facility. Just last week, they received their first shipment of Aqua Advantage salmon eggs. Now these eggs, when harvested, will become the first genetically modified animal ever approved for consumption in the US.
So these are the eggs. They don't look like much, but they're the culmination of decades of research and debate over whether genetically modified animals have a place in our diet.
We're going to see a 2 billion person increase in the population in the next 30 years. So we're going to have to feed 28% more people. So you start with that premise, and then you think, how is seafood going to play a role? Wild-caught salmon is basically at full capacity. Other farmed method is ocean cages, and they have their own set of challenges because those fish are exposed to climatic conditions, predators, disease.
And that's where AquaBounty's fish come into play. 30 years ago, scientists figured out how to produce a salmon that grows to market weight in half the time as conventional salmon. To do this, they injected the growth hormone from a Chinook salmon into an Atlantic salmon, along with a hormone from the ocean pout to ensure the rapid growth is constant. These super fast growing salmon have two big advantages. First is that they need a lot less food.
They have what we call an improved feed conversion ratio. And what that means is for every pound of feed that you put in, you get more than a pound of meat out. So if you think about cattle, it takes about 8 pounds of feed to create 1 pound of meat. With our fish, you put a pound in and you're getting like 1.25 pounds out.
Since they grow faster, Aqua Advantage fish require 25% less food than conventional salmon. The second advantage of fast-growing salmon is that you can simply produce a lot more of them, and that's what unlocks Aqua Bounty's other upside. They grow their fish in what boils down to big tanks, but the facility is actually pretty high-tech and has some huge upsides. Super tight controls on the conditions prevents disease. Nearly all of the water is recirculated, so it's ultra efficient, and you can put them pretty much anywhere. The problem has been that it's so expensive. But when you have fast-growing fish in there, the numbers start to balance out in a way they never have before. All of this may sound great, but it's been far from a cakewalk. Genetically engineered anything is rife with controversy. The long road to market is the result of an approval process that has surfaced two consistent and pretty reasonable questions that arise when considering genetically modified animals. What if they get out and overrun native populations? And more prominently, are we sure they're safe to eat? At the Indiana facility, Pete, the farm manager, is the point man for making sure the first one remains moved.
We have, first of all, on a really large scale, we have geographical location. We're in Indiana. There are no native salmonids. Nevertheless, inside our units, we have a very high level of physical containment. Every possible escape route out of the facility, water discharge points, pipes, they have layers of containment, physical barriers in place that will prevent the passage of the fish. And we do have numerous redundant layers.
On top of the physical barriers, nearly every single fish is sterile. If one gets out, it can't breathe. So then the question remains, is it really safe to eat? After decades of asking the same question, the answer from regulatory bodies is yes. Why did it take that long? Well, since there was nothing else really like it, there was no process for it.
So in the case of animals, they didn't have a really good law, so they used the Federal Food, Drug, and Cosmetics Act.
This is Dr. Eric Hallam from Virginia Tech. He was brought in as an expert during Aqua Bounty's approval process.
What they said is the transgene is basically a drug because it's altering the structure or function of an animal. In a traditional food, like Atlantic salmon, it's not regulated at all for that. In fact, we learned a lot about the biochemical composition of Atlantic salmon because Aqua Bounty had to go and do baseline research on what is conventional Atlantic salmon. Then they had to show rigorously that theirs was no different.
And ultimately, that's exactly what the FDA decided.
Basically, the way that FDA typically put it, Aqua Bounty salmon is Atlantic salmon. That's it.
With all the regulatory questions settled, Aqua Bounty has the green light to sell their salmon on U.S. shores. And now the looming question is, what does this mean for the industry? Does Aqua Bounty's long fight with regulators clear the path for more innovations like it? Or does it serve as a warning to anyone else trying to bring bioengineered animals to market? Dr. Allison Beninanam from UC Davis fears it's the latter.
I've worked in this field for, almost 30 years, and there's one product that's ever got to market. I mean, how depressing is that? Because there's been a number of really useful applications that have been developed over the last 20 years, and they're all basically sitting on the shelf because no one has been able to raise the capital to bring them through the regulatory process. But the problem is that it precludes the use of that technology in food production and, more concerningly, in developing countries. The average first world consumer has no idea that their choices are actually kind of impacting the ability to use innovation in the developing world. I always find it strange to be categorically opposed to technology. I think you have to look at it on a case-by-case basis. And I think most people want healthy and safe food and also to reduce the environmental footprint of our existence on Earth. And quite honestly, I can't think of an industry that more requires, innovative technology to reduce the environmental footprint of food production.
Conventional methods are not going to feed 2 billion extra people on this planet. And it certainly is going to happen without some pretty significant impact to the environment. We're proud of the fact that, we solved the problem and we use science to do it.
Thanks for watching. If you like the future of
So itu
Wow.
dibincang berkenaan dengan future food.
Yeah. But it seems not really scary at all when you look at the fish.
Because kalau misalnya, because there are two different school of thought when it comes to GMO dan, for example, hybrid. Some group think that hybrid is GMO because hybrid is also you change the genetic because
that's right.
you combine two different genetic, the species A and species B. But then GMO actually is created in more advanced technique, normally in the lab, whereby you do some genetic slicing or some real amendment of the genetic material. Unlike hybrid, is just like, you know, we just mix the sperm and egg of two different species. That's all. We don't do any. So there's always controversial punya discussion when you see this GMO and hybrid. So it depends on, let's say, okay, we put it this way, hybrid is GMO. That if that's the case, meaning we have been eating GMO since a long time ago. Our great-grandparents, our ancestors are taking GMO because hybrid is occurring naturally in the wild also.
Yes, that's right.
Yeah, so it's not so, like you said, Bu Umi, nothing so dangerous about it, right?
It seems like, it seems like only just grow the what is that, the fish bigger. That's it. But yeah, of course, maybe the one who expert in this aquaculture, I mean, looking at the process, they only just like modified the genetic. So then instead of growing this size, growing into bigger size or something like that. It's because of anything. But I mean, they didn't put any chemicals or maybe pollutant or heavy metal or any dangerous substances into the fish. No, I don't think so.
Right, you're right.
Yeah.
It's not like the genetic material in fish will be transferred into our body also, right?
Yeah, that's right. You know, when I remember about the chicken, probably if you recall it, you know, when the chicken, you give growth hormone so that they can fast grow and mature fast, then it impacted your body, and then your body, if you eat a lot of this kind of chicken, but then this fish is not, it's really different. I mean, they didn't given they didn't given like growth hormone, even only just slightly changes the genetic or something. Maybe they refuse because of the moral issue or something like that, probably. I don't know. Professor. So that
that's why I said there are mainly two different school of thought, whereby one say, you know, it's GMO, the other group say it's hybrid. They're not the same. So I'm on the group that's saying that they are not exactly the same, but I also cannot find, like you said, what is the so bad thing about taking this GMO fish, for example. So
yes, I think so, but if I'm not mistaken, I heard that this kind of fish cannot be hybridized again. Is that why?
Sorry, I don't get your answer. Your question.
In easy way, ikan ini tidak bisa dihibridisasi lagi gitu. Is that right?
Ya, let's say tadi itu sudah hybrid, lepas tu dihybrid lagi, crossbreed.
I mean, setelah after you get the bigger fish, apakah ikan ini still can be hybridized with?
Ada yang dibuat crossbreeding, ada. Maksudnya tadi misalnya tiger grouper macan yang giant jadi hybrid F1. So F1 ini kami cross semula dengan dia punya bapak, which is the
Okay.
giant, cross breeding.
Cross
Pun boleh
breeding
juga, ada
again.
juga, ya ada juga, tapi so far our cross breeding tidak jadi, but I know there are places that they are doing that and it works. So
Oh,
memang,
okay.
ya dipanggilnya crossbred lah, di
Yeah.
cross semula dengan dia punya parent.
Oh, okay. Then I was thinking like this giant salmon, if they are they do the crossbreed again with the small one. I was wondering with the offspring of this two.
Yeah, normally if they want to cross, not with the less superior species, but normally they will choose a better species, so that we hope that we will produce much better hybrid.
So it won't come back to the previous.
Yeah.
Oh, okay. Very interesting discussion, Prof. Yeah, this is really actually about our food, but we also have to think about this safety or something like that. It's
Yeah, we have to know what we eat, I think. As long as we know what we eat and we know that it is safe, then I think it should be okay for us to consume.
Yeah.
The importance here is the traceability. We need to know what they're eating, where are they being farmed, whether or not the water is good, or are they feeding the right feed. Let's say some farm, they are feeding their fish with, like, animal offal that is already rotten, that is not clean. So we afraid that this kind of practice is going to affect the quality of the fish, and of course affect the health of the consumer, I mean the human, the people that and it will bring a very bad image to aquaculture. That is what we don't want to happen. Because,
Okay, thank you so very much, Professor Rosita, for your lecture today. I think we come to the end of our lecture today. So thank you again. And we still have to see you again tomorrow.
Sure. I'm looking forward to see you all every day.
Yeah.
This not happen very often.
Yes, I think so. So probably I will give it back to the committee. Pak Jailami, maybe we can have a photo session.
Okay, Bu Umi, maybe we will take a photo session first before we close. Everybody, please open your camera if you don't mind.
Oh yeah, okay.
All right.
All right. Can everybody open the camera?
Please, I would like to see your face. I want to post this in Instagram or Facebook.
Yeah. Come on. I think you don't be too shy.
Apa yang ada yang belum mandi kali?
It's already like 12 o'clock almost. Yeah. Okay. Come on, dear students. Can you turn on the video for a few minutes for us to take a picture? Yeah, that's good. Come on, don't be shy. You should meet your professor. Your lecture today. Okay.
Okay, I will count.
Yeah, okay, I think we can take a picture. Okay.
Okay, 1, 2, 3. Smile, please. 1, 2, 3. Again, once again. 1, 2, 3. All right.
Okay.
Thank you.
Thank you. Thank you very much, everybody. We will see you tomorrow. Okay. Thank you, Prof. Rosita, for your lecture today.
Thank you,
Yeah.
Thank you, Febriani and everyone.
Tetap sehat ya.
Yeah, inshallah. I'll see you tomorrow. Let me know what time we start tomorrow, yeah?
Tomorrow we will start at 7:30.
Okay. All
Just
right.
today for 8.
I see.
Oh,
Okay.
okay.
Thank you.
Yeah.
Thank you.
Thank you, Prof.
Bye.
Rosita.
Okay.
Prof. Rosita.
Terima kasih. Oke, tetap ya jadwalnya ya, Mas Delami ya untuk besok ya, 7.30
Iya, Bu,
ya.
jam 7.30. Saya juga nggak paham kenapa di hari ini jam 8. Mungkin ngejar jam tayang aja biar enggak.
Oh gitu.
Ya.
Oh iya, besok sampai jam berapa lagi?
Seperti biasa, Bu, jam 7.30 sampai jam 12.
Oh gitu. Oh ya. Mungkin untuk untuk besok mungkin untuk sampai session gini sebenarnya itu ini menurut saya karena jam 7.30 sampai jam 12 kan hampir 4,5 jam ya. 4,5 jam itu kita bagi jadi 3 session gitu, Mbak Febri. Jadi 1,5 terus ada Q&A, terus 1,5 lagi Q&A gitu. Jadi ada 3 session Q&A gitu maksudnya. Nah jadi berarti kalau 7.30 ya sampai jam 9 ya. Soalnya kalau di luar negeri itu memang harus ada break kalau kuliah panjang kayak gitu tuh. Nggak bisa kalau kita nggak break. Beliaunya juga butuh minum mungkin gitu ya setelah itu. Nah oleh karena itu ya kita anu aja langsung kita ini kan ya kita jelaskan jam 1,5 gitu. Jadi ada 3 Q&A. Nah, untuk itu saya mau minta bantuan nih Mbak Febri nih besok untuk yang 7.30 sampai jam 9 tolong di-handle dulu ya. Mbak minta tolong nih Mbak Febri.
Kalau besok yang co-moderatornya Pak Ekwan, Bu.
Oh gitu.
Besok moderatornya insya Allah saya, Bu, dari
yang untuk S2?
Iya, untuk S2.
Oh, Pak Ahmad ya? Apa saya salah jadwal?
Oh gitu. Lah kok di jadwalnya kok saya terus sampai berapa hari itu?
Sampai ini hari Rabu kan, benar kan?
Iya.
Oh iya
Ya,
betul.
Senin sampai hari Rabu Bu Umi, hari Kamis saya, hari Jumat Bu Uun.
Oh gitu. Oh alhamdulillah, alhamdulillah, aduh ya Allah.
Besok Pak Day sama Bu Rani ya?
Oh iya. Oh alhamdulillah karena memang pagi itu saya sebenarnya kalau hari Senin, Selasa, Kamis itu saya memang ada acara gitu loh kalau pagi sekali itu. Selesainya baru jam 8:30 gitu. Makanya ya Allah, alhamdulillah wis sudah kelar tugas saya.
Ya, matur nuwun Bu.
Iya,
Sudah
kalau
bersedia menemani.
Aduh, iya. Ya, saya juga terima kasih nih. Alhamdulillah bisa menjalankan ini. Thanks for having me here gitu ya. Cuma memang gini, saya itu actually ya kita itu harus mensupport gitu ya. Maksudnya mensupport itu harus ada question gitu. Kalau perlu itu come on, dear students, kamu bisa mengajukan apa saja. Kalau tidak ya terpaksa kita yang punya pertanyaan tapi disuruh mereka yang bertanya. Jadi biar flourish gitu kondisinya itu. Jadi kasihan kalau nggak ada pertanyaan itu kan as if apa gitu. Terasa nggak enak juga sih. Makanya saya kalau nggak ada question tuh selalu mencoba untuk berdiskusi dengan beliau supaya tidak empty gitu. Jadi tadi